misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat earth in its place. Here comes the smackdown.
Welcome everybody to Saturday morning, but it's still always Toons Day at the House of Toon. Welcome to everybody. I just realized before I started I had accidentally set the start time to 9:45 p.m. instead of a.m. Apologies to anybody that was that's now saying, what is going on? How come it started so much earlier than the video said? Well, that was my fault, my mistake. But yes, the event begins in just under 15 minutes. The panel with Dr. Shiva arranging it, and it is was agreed to be 3 globe, 3 flat, and Shiva moderated. But Shiva's obviously a glober. He's not pretending about anything, but he's saying let's do some science, and so he put together the idea for the panel with well, it was actually like between him and Flat Earth Dave, when Flat Earth Dave somehow snuck his way into talking to Shiva. Shiva's like, well, let's go test it, and Dave's like, yeah, let's test it. And then Dave ran away like a scared little chicken. Dave knew that if Flat Earth was tested and he was part of it, that his grift would end and he would no longer be able to vacation in Florida off the backs of the gullible sheep that pay for his app and the subscription to it. So he ran away screaming, you know, to protect his grift. And so when your grift line, I suppose, Dave, that's what you do. You run the heck away from any testing. Anyway, other people were then, in the meantime, invited. An open invite was out, and specific people were invited, like Eric DeBay, Mark Sargent, Nathan Thompson, and some others were very specifically invited, and they did not show. They didn't even respond, according to what Shiva has said. So no surprise whatsoever that they had no intention, no ability, no possibility that they could participate in a panel where we do science. And the critical part of what this is that we both sides put together a model that produces predictions based on our model for the experiment. So last week we had the preliminary panel where we agreed on 2 different experiments, one proposed by Globe, one proposed by Flat. The Globe experiment is take our model and compute the consequences of the position of the Earth and Sun in 3-dimensional space. So, and how that's done is we were given a date, time, location on the surface of the Earth, and what will be the position of the Sun? Where will we see it? So this takes apparent effects. It takes optical effects into account. So the Globe will then mandatorily need to produce a model that says, well, at that date, time, location, it will be at this azimuth, this horizontal angle, and at this zenith, this vertical angle. Those 2 things then are output from the Globe prediction. Same for Flat Earth. The Flat Earth must present a model that predicts the location. Now, will these flat earthers show up at all? Don't know. It did not go well for them last week. If they do, will they bring an actual testable model? And if they do bring a model, will that model just use the Globe? Will they try to hide the Globe somewhere in the math? Now, flat earthers suck at math, and so when a flat earth gullible sheep is presented with math, they look at that, they're like, they don't understand it. And so they go, oh, okay. And then they're just happy with it. But if it's lying about stuff and actually embedding globe geometry in it. But we're not ignorant of math. If they try to hide that, it will be very apparent. We will show it and then say, thank you. You have used the globe to predict the location of the sun. Globe confirmed. The prediction of the sun using flat Earth would be very obvious how you do that. And we will see what they do. So anyway, that's number one. Number two, flat earthers proposed using the instrument landing system for an airport to compute whether or not to compute the intersect where an airplane intersects it. We'll go over this. I'm not going to go into too much detail, but basically a beam is sent out from the runway at a certain angle. And if the Earth is flat, then you can compute where the airplane flying at a constant elevation will intercept that beam. And if the Earth is curved, you can do the same, and they will be slightly different, mostly because if you think about the globe, there's a curve to it. And so when you're a certain distance away from that transmitter, your vertical vector and the vertical vector of that beam are different. And so you can differentiate that because you'll intersect at a different point for flat or globe. That's the idea. And so we've put together a model for that for the globe. And flat earthers have already provided their model for flat Earth. Maybe they'll adjust it in the meantime. But anyway, so that's the status. I haven't yet gotten into the Zoom call. I'm going to do that right now, and you're going to see a little of the behind the scenes making of the sausage, as I say. As I join in, you'll see some of the preliminary stuff here. All right. I gotta put in my credentials here in the meeting. There we go. Join. It starts in 6 minutes, so I won't be. There we go. All right. So it's not in yet. It's just, the meeting, the meeting organizer hasn't yet begun the meeting. So that's where it's at right now. So we got a little bit of time to let's see here. Okay. I registered. It sent me a follow-up. There it is. Oh, I gotta turn on my camera. There it is. Okay. Make sure all that is right. Okay, good. Okay. So there it is. No sausage making visible yet. So in the meantime, Dan O, who runs the channel Unfornicated, Dan O and I have been working together on this and done a little bit of work with Dr. Pete. I don't want to get his name wrong. He's somebody that Dr. Shiva knows, Prabhakar, something like that. Anyway, a little bit of work with him, but he's going to be doing the write-up. So this will be potentially up and published in a journal of some sort. And so everybody participating will be listed as co-authors, and Dr. P is doing the a large portion of the write-up. He's been taking notes as we do these different things. So I have four. So the way we split it up is Dan is put together the model for the globe for the angle and the two different angles to the position of the sun. And I've put together the globe prediction for the ILS intercept with help from two people. Particularly, I want to mention PD194 put together a model a while ago and using this particular intercept. And then I needed to do some customization, but I'm not super good with GeoGebra, which it was done in. And so Janusz Takas was super helpful modifying some things. So I have citations ready to go. And I'll give the link during my presentation so everybody can go look at the actual GeoGebra model and play around with it as you want. Stefan Venny says, I'm sure you'll need to allow an extra hour for them to figure out Zoom. Yeah. Well, they did get it going last week. Last week, what happened is, of the 3 flat earthers that had volunteered and agreed to the date, one showed up on camera, ready to talk. A second one was there, not on camera, apparently driving the entire time. He basically introduced himself at the beginning and then said thank you at the end. And that was it. And then a third one, going by the name Globe Slayer, who's active on X, did not show. He had to work. He did not, something didn't happen well. He didn't get along well with the other participants or something. I don't know exactly, but he didn't show. I'm not expecting that he's going to be there today. I don't know if any will show up today because they were tasked with, think about this. They agreed to bring a flat earth model that predicts the angle of the sun for any location on the surface of the earth for any day. They agreed to that. And so will they show up? Will they even show up? I can't imagine that they'll show up because they know it cannot work. It's been tested so many times. Will they use the typical Gleason map, the circular one where it's got Antarctica around the perimeter? Will they use that? The one that Flat Earth Dave says is the real map of the Earth? Well, that won't work very well because just the azimuth angle isn't right. It's never right. The elevation, of course, can never be right either. How do you have an actual science based, evidence-based model for flat Earth where the sun sets? Not just sets, doesn't, right? They're like, it goes away. It doesn't go away. The sun is the same width as it was midday when it gets to the edge of the horizon. It's the same angular width. And then it gets blocked by the edge of the horizon progressively. How does it do that? There is no science and evidence-based method for that known to anybody. And flat earthers, of all people, can't do science. They don't understand science. They are quite terrible at it. So they're among the people that could put together a model. They're the bottom of the list of people that could put together a model. So funny. Jim Daniels, brother to Jack Daniels, of course, gifted 10 memberships. Appreciate that very much. Jim, what's it like being Jack's brother? It must be tough. Is he just like always smashed all the time? I'm kidding. Did you hear a dog crying? That's Donkey. He's in the room. The door is shut. So like my dog Donkey likes to. Okay. Oh yeah. It looks like there's a little buffering. Donkey likes to sit underneath my desk, and but then I come in here. I'm like, all right, it's time to start. I shut the door so that they don't hear me so much in the rest of the house. And he's now he's trapped in here, and he has a big case of FOMO, fear of missing out. If there's someone doing something, he's like, oh, I need to go see it. So. Yes, we did name the donkey after Flatside. No, actually we didn't. So what time is the Dr. Shiva thing happening today? It is happening 52 seconds ago is the start time. So I'm in the meeting in Zoom waiting for it to start. And so I do have prepared a pull it up here. Come on. I do have Dr. Shiva's got a his live stream. Like, I'm gonna have the chat. There it is. I'm gonna have the chat from the live stream up on screen. Oh, now it's up. It wasn't up before, so they're just now getting things going. I think a little bit late, but not a big deal. Oh, Man of Stone is already in there flapping his face. He's here. He says, I'm the sole author of the only valid experiment in consideration, and it is preposterous that I do not have a seat at this table. Well, Shiva did not like Man of Stone's treatment of him on X and said, yeah, you can get the hell out. As it should be. So there's his comment where Mr. Butthurt, Man of Stone, is crying about it. Now, as is always the case with flat earthers, Stone's science is rubbish. Flat earthers lack the ability to understand margin of error. None of them ever consider margin of error. So last week, when we were putting the stuff together, I asked Kevin, who's Stone's puppet in this, what is the margin of error of something? And
recording in progress.
And he said 0. Now, there's no such thing as a 0 margin of error. So, all right, the meeting has begun. So let me get it up on screen for you all to see.
Good morning, everyone. This is Prabhakar.
Good morning.
Michael, Dan, and Ryan.
Prabhakar, how you doing?
Good.
Good morning.
Morning, Mike.
All right.
So we should be starting in another 10 or so minutes, I think.
Okay.
Yeah.
Okay.
Ryan, good morning.
Hey, how's it going, Dr. Rocker?
Good.
How you been?
Good.
I hadn't seen you in a little while. Or talked to you.
Yeah, I see you've been busy.
Yeah.
Ryan, you're down in Texas, right?
Yeah, I'm in Dallas.
Okay. Well, yeah, I know the area well. I used to go to Plano for work on occasion.
Yeah.
Everybody is down in Richardson and Plano. It's in telecommunications, so I used to make that trip every once in a while. And it's a nice change from the Northeast, especially in the winter.
Yeah, don't come down here in the summer, 125 degrees, but...
Oh, God, no. The humidity down there, I have, my stepbrother lives in Houston. He's always asked me to visit. I'm like, dude,
yeah.
the only time I go down there is in the summer, and that's not high on my list.
It's pretty rough.
This is Dr.
Hey, Dr. Shiva.
I just have to jump in. Oops, that's worse. I just have to. Who's that?
Okay.
I see 2 copies of you, Dr. Shiva.
Oh. Why is that? Who's that?
Let me mute.
Not sure.
Who's the other?
No, I'm on the video. I'm not sure who. Suresh also has joined from a different login.
Is that still? Let me. I'm going to make you host, Prabhakar.
Okay.
And then I'm back. Okay, let me see. Can you remove both? If you can remove me?
Yeah. Okay. All right, Dr. Shiva, I've removed that other one. Can you hear me?
Might have removed the correct one. I just put in the link to Shiva's.
Can you see me, Prabhakar?
Yes. Yeah, I can hear you now. I don't see you yet.
Yeah, you can hear.
To Shiva's video. So if you want, you can pop in and talk with the Flurfs in there. Tim Brown, funny. Anyway, so yeah. Go. All right, they're talking. I'm sorry. I muted them. All right, so yeah, go jump in the chat there. Man of Stone is already in there complaining. He's a bit of a sad person. Yeah, I'm live streaming right now, so I was talking to my my audience. Yeah, sorry. I muted myself so you didn't hear what I was saying. All right, muted myself again. Let's see here. Clean up a bit of that. All right. Yeah, jump in the Man of Stone. That's all you guys have. Ad homs, worse than pathetic. Typical flat earther. He doesn't know the difference between an insult and an ad hom. But also, Man of Stone wasn't invited because of extreme douchebaggery. That's not an insult. That's a description of how he was acting on X. So, yeah, let him know. They love to try to control the narrative, and they're not in an echo chamber here. So if they come in there and they start whining about stuff, and there's just other flat earthers affirming them, then that acts like an echo chamber. But this isn't an echo chamber. You all can go in there and set them straight. So have your voice be heard over there. And I like the same thing here. I like if flatties come in here, they can comment. And unless they're being particularly horrible, then, let them stay. Let them come in and make a fool of all flat earthers. So Peck, who's not a flat earther, is sarcastically saying flat, 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 at. Thank you for that member chat, Peck. So is he an actual doctor, unlike Rasa? I do believe that he is an actual doctor, yeah. Al Bergen says he is an insult to actual douchebags. Donkey, what are you doing? He's like, I want to go out. There's stuff going on. Go ahead. You want to sit under the desk? You can. Go ahead. He's kind of a baby sometimes, There he goes. Okay. There you go. We got some people in there. You will see it fully quantified when Kevin presents it. I'm not going to spill it out here in the chat just for you. That's funny. Fully quantified. I mean, I've seen what they've done so far in their preliminary stuff. And Kevin last week listed off what he thought were the variables that he needed to take into account. And none of the variables that he took into account were very important variables that he took into account. Pretty funny. Things that have things that have very little to do, very little impact. We're like, we need to take these into account. But things that do have a significant impact, like the margin of error of the angle, which he had no idea for. He's like, oh, the error is 0. Of course it's not. Not 0, but he thought it was. So I have right here. Let's see here. I have right here my Flurf Bingo. Make sure you get your Flurf Bingo. We'll see if it happens. And then here's their map. This is Flat Earth's map. For 150 years, this has been the map that they've used. And will they continue to use the same map? Or propose something else? It doesn't matter. There is no map that can work with actual geometry. So now Ryan Shea is there. Ryan is the flat earther that did not speak last week. He was driving. Kevin, I don't see in there yet, but I don't know why. I don't know where he is. Man of Stone. He didn't say 0. He mentioned a 1% error measurement measured in the vertical component at 35 nautical miles. Where did they get that from? No idea. Actually, he just invented that number on the fly. He just did. Now, the thing about ILS is it's designed for a specific purpose, and its purpose is not measuring the things that is being asked to measure, which is fine. You can sometimes do that, right? You can utilize things, use them for something other than their intended purpose, but you need to then, be very careful, because there are things then you may not be aware of. But this is important. ILS is certified for 10 nautical miles. That's it. Beyond 10 nautical miles, there are no certifications or guarantees that are necessary for airports and to use, or things from the FAA. None of that is in there. None of that is required. So past, and they're proposing to do it at 20 nautical miles out. So what is the margin of error certified for the instruments? There is no certified margin of error. The best you can do is use the margin of error at 10 nautical miles. That's the best you can get. So it's at least that much, potentially more. And this is what's funny about flat earthers, right? They think that this beam that is sent up at a certain angle, they think it's pencil thin, and that you can just exactly get the very precise position of the plane using that. Ridiculous. So this is pretty good here. Man of Stone, you know what a scientific model is, right? I mean, right? Man of Stone, David, he didn't say 0, mentioned 1% error measured in the vertical, which is just invented. Let's see. Man of Stone says, Grug, how about you shut your yap until you see the actual figures? Oh, that's funny. He's so triggered. David Jacques says he said 0 at one point. Pay attention. What is the timestamp? Man, it's Wesley Grand Leonard says, how did you calculate it? What is your uncertainty budget? Man of Stone says, don't care, David, about the 0 at one point, of course. August Cross says, let's see. No, he's talking about something there. Man of Stone says, we have what was requested and will now present it. Do they have the actual model for flat Earth based on this, which is what I know Man of Stone thinks the Earth looks like? He thinks this is the Earth. Man of Stone thinks this is the Earth. It's so funny. How can you use this? You can easily use this to determine the azimuth angle and zenith angle to the sun. But every flat earther knows it's wrong. So what will they be bringing? I'm so anxious to find out what kind of desperation they will be presenting today. It's going to be hilarious. What else we got? Wesley says, Man of Stone, and the no uncertainty budget is not the same as your lack of income. David Jacques says, Man of Stone, but you just said I was wrong and need to pay attention. Do you care or not? Very weird. Oh my goodness, I love this. Guys, giving him the pushback that Man of Stone needs. I like this. Pretty. I don't know if you're enjoying. I'm enjoying narrating this exchange here. Wesley says, Man of Stone, one of the first things you do before an experiment is come up with an uncertainty budget. How do you not get this? Grug says, so you admit it was incorrect the last time, Man of Cope. And of course, people can make mistakes. You can correct them. That's the beauty of science. Everything in science is provisional. There's always a next improvement allowed. And certainly people can make mistakes. And you own them, right? You state, hey, that was wrong. Let's move forward. Here's the better way to do it, the correct way to do it, whatever it is. So let's see here. We got well, I don't know what this guy's talking about. Where's Dave Weiss? Didn't he interview Dr. Shiva to start this discussion? Of course, Flat Earth is a grift for the gullible. Oh, yes, it is. Man of Stone says, can someone give the boot to August Botch clogging up the chat with garbage? I that's probably about right. I mean, I don't know what this is about. He's certainly not being very useful in here. I mean, maybe he's got some baggage about some other topics. So, CK Shifty made up a few more lies about Dave and excluded him based on those lies. Shifty? Oh, is he calling Shiva Shifty? Man, the stuff about Dave is documented. So, DT2PZ0 just says, just letting you sheeple know you are outside your echo chamber. I don't know what he's talking about. Is he? Oh, he's a flatty, isn't he? Oh, there's CK. There's CK. In my chat. Glad to have you here. Why is the guy at the top talking? Why am I talking, DT2PZO? Why am I talking? Because this is my show. Shiva's hasn't started yet, so I'm just waiting for that to start. And I don't know where the flatty is, where Kevin is. No idea. How come the live stream isn't going on Shiva's channel? Because it hasn't started there yet. So DT says I don't ban people. Well, flatties certainly do, but DT, I don't know. Do you actually have a channel where you have an opportunity to ban people? Let's see here. Your channel has nothing on it. So I don't know what you're talking about with you don't ban people. Your lack of a channel would be all that's necessary to not ban people. Mike Dude says, is the crazy foreign guy going to show up? You mean Kevin, I think. And I don't know. I think he would be a fool to show up because he knows he doesn't have a model for the thing that he agreed to present. So, you know, I would not be surprised at all if he didn't show, you know, like removed everything, like just went into hiding for a while. So I wouldn't be surprised at that. So anyway, DT2PZO, whatever that is, I don't know what is that an abbreviation for something? Anyway, if you think you're so smart, you can just shoot me an email, mctoon@mctoon.net, and you can bring your woke information. You're broken for your hold on. Yeah, I'm ready.
Gallery mode, I think Suresh is here too.
Yes.
I'm here.
Do I have to put it into gallery mode or can anyone do that?
It is in gallery mode currently.
Oh, I see your thing with those cool lights in the background. Is that you?
Yeah.
Oh, okay. Let's see what's going on. 1 second.
Kevin's having internet issues.
Oh, he's not here yet?
I don't blame him. He definitely should try to have internet issues right now.
Who said that?
Mike, we called that one, didn't we?
We did. Oh, darn it. I can't mute myself and then unmute.
I can't hear. Mike, can you? Can you guys? Hello?
Sorry, I muted myself and I can't unmute myself, so I won't mute myself anymore.
Yeah, I've already done that twice now,
Yeah.
Mike, so I just gave up.
Sorry. All
All
right.
right, so who are we waiting for now?
Waiting on Kevin.
Okay,
I'll be back in a minute, Doctor. Just 1 minute.
okay.
There is some static white noise that came on. It might be yours, Dr. Shiva.
Really? Like, is it really bad?
Yeah, it'll be annoying. Well,
It's like a little hiss.
yeah, whenever you talk, it'll come through.
You have a fan on or something?
Yeah, you know, the fan on the computer is on.
Oh. Been working all day, so it's heated up.
Yeah.
Or you've been hugging it because it's a little chilly in the Northeast today.
Not sure why it's so loud, though. It's normally not like this. I hear it.
Huh.
If I do,
Yeah,
Goes away.
that was definitely you.
It goes away.
when I talk, I'll do that, and I'll try to keep myself muted. Okay.
All right.
Kevin is in the waiting room.
And what about Bobby? Is he coming?
I can't imagine that he is.
I haven't heard anything from him.
I heard he was compelled by Dave Weiss's group not to come.
There was he sent me a cryptic message about being pursued by people or something. I don't know if he doesn't get along with Dave's crew. There's a lot of infighting. So
Well, the Ether Cosmology group did have a space last night, so maybe they chased them off too. Who knows?
Okay. So is Kevin in? Kevin's got to be let in. Kevin? I just let him in.
all right.
Is Kevin in?
I don't see him yet.
That he's joining.
I see 2 Sureshes. Hey, there's Kevin.
Kevin, Ryan, Dan, Michael. Okay, Suresh is just helping us produce it, take it live. All right. And then we have people in the waiting room. We're going to let them in. So the people in the waiting room, obviously mute them, right? Prabhakar, you're host, right?
Yeah.
Okay. There's a couple of people. These are observers. Okay.
You hear me well? Didn't get my good phone microphone. You
Yeah, we
still
can
hear me
hear
good? Okay.
Yeah, we can hear you.
Yeah.
So how about my request that we start with the ILS first, or how are you? Because it's such a big topic, the sun. I don't know. We finish the ILS and then start the sun.
Yeah, I think we'll do the sun first because we'll just get that out of the way then. Just present the models, and then we'll go to the ILS. That's the way I had it structured because that's the way we did it last time. Let me ask people, we're streaming this live. Are people, it's sort of, I understand last time when I was looking at the videos, were there other people, Kevin, Stone, and everyone in a Telegram group that you were bringing into this discussion? Because that wasn't the agreement.
I didn't have any agreement about this. It was not. We were not talking, but. But I had, like, he messaged me.
Yeah, because when I was we were, because we're doing the transcript for the videos because we're going to convert this into a paper. And there's something popped up that a bunch of people are on Telegram, and you were communicating with them.
No, not in a group, nothing like that, no.
Okay, but were they live? Were you communicating with
I
them?
don't know whom are you talking about? Which group? I don't know which group you're talking about.
Well, there's a Telegram thing. I don't want to go over the video right now. But the goal was we invited people. Some people didn't come. Some people were not invited because of their duplicity, he being one of them. So I just want to make sure we're following the guidelines of this and we're not doing something that violates the effort that I framed for this summit. So I'm not going to speak
Sorry,
about
I still don't know what you're talking about, which Telegram groups I should communicate with while the thing...
No. Okay, listen. So during our last broadcast, were you communicating with others when it was going live?
Not in any group, as you mentioned, no.
So there's no one else you were communicating with?
I already told you that Stone messaged me sometime, but I couldn't even read it. Sometimes I...
Okay.
Yeah.
So, but just for the record, you weren't communicating with any group during our broadcast at all?
No.
I just want to get that on the record. Okay. And the second thing is you're not doing that now in chat groups with other people as you're doing this communication today.
As I haven't done it last time, but...
Okay. And same with you, Ryan. Just to be clear, Prabhakar, you, Kevin, Michael, I just want to make sure.
Yeah.
Just me.
No communication.
Okay. This is the science panel here. The only person missing is a guy called Bobby. And there's some evidence that he may have been forced not to be part of this group anymore by Dave Weiss's group. So, which is unfortunate. But today's day 2, and we're just going to jump right into it. Are we ready to broadcast, Suresh?
Yes, Dr. Shiva.
Okay.
Let me know when you're ready, Dr. Shiva. I will hit go live.
1 second. I have the, just going to review what we're going to discuss today. All right. I think if you can just give me a countdown, Suresh, I'd appreciate that. Thank you.
And you want me to bring up the thumbnail, right?
Yeah. And then and then everyone will be able to see everyone, right?
Yeah, in the beginning, we will be in the gallery mode. And as we speak, I'll just spotlight the panelists.
I see. Okay.
Yeah.
All right. That's a lot of work, but that's okay.
Yeah.
Go ahead.
Okay, so I'm sharing the thumbnail. And let me know when you're ready. I will hit go live.
Yep, I'm ready.
Okay. So, going live in 3, 2.
All right, welcome everyone. This is Dr. Shiva Ayyadurai, and we have the second day of our Flat Earth Summit. And we were scheduled to have 3 panelists on the round Earth side, 3 on the flat Earth side. However, one of them on the flat Earth side has gone MIA. And there's some evidence that he was forced by one group not to show up because he may have alternate views, which is unfortunate. So what we want to do today, as we discussed last week, was today is going to be really a day where the rubber meets the road, where each group has to produce the hypothesis, also known as the mathematical models, for each of the 2 experiments. And to keep this clear for each mathematical model, so the round earthers are going to propose a mathematical model for the sun experiment, and the round earthers are going to propose a mathematical model for the airplane experiment, which we'll get into in detail. And then the flat earthers will propose their mathematical model for the sun experiment and their mathematical model for the airplane. That's what the goal is. And then in each case, we'll also agree where the independent data source is going to come from, how the data is going to be captured. To validate those models, we're going to use the scientific method. So let me sort of jump into the quick presentation how today's going to proceed. Probably do the window. So just want to make sure, can everyone see this? Prabhakar, can you see this?
Yes. You haven't shared anything, but I see that you're about to.
I did share. Oh, that's weird.
It popped up there, then it left.
Oh, that's
Zoom is being Zoom again.
okay. I may have to share the whole screen. Zoom does this sometime. So let me share the entire screen, the whole desktop. I guess you guys could see that, right? Yes?
Yeah.
Yep.
Okay. So this is day 2. We want to welcome, we invited people if they wanted to join the Zoom panel here. So there's a few people here. And then we're also broadcasting this on all different channels, YouTube, Twitter, I think Facebook, etc. So we want to welcome everyone. I want to again review the history and mission of the summit. Then we want to go into the format. We want to review day 1, and then we're going to go into the sun experiment. Round earthers and flat earthers will represent their mathematical models and the independent data sources. And then the airplane experiment will be, again, gone through the same models. There is a very, very important question that came up last time on the need to include error margins that was agreed upon. And then we'll go to next steps and we'll summarize. So day 1, what we did was we reviewed the scientific method. Some of you may remember this. The scientific method begins with an observation. Here's a simple example we went over last time. Again, I wanted to review this because there may be some new people, but in the scientific method, you observe something in nature, whatever, even in non-natural settings. You have a force upon a mass of a car, and the car accelerates. So you see this phenomenon, and you may then make a hypothesis, and you may say that the relation between force, mass, and the acceleration, represented as a here in this equation, is related to F equals ma squared. Okay? It may be right or not, but that's your hypothesis. You're saying that the force is equal to the mass times the acceleration to the power of 2. Okay? So today, one group has the hypothesis that the Earth is round, and relative to that, we're going to look at the observation where the sun is, relative to a person observing it out their window, for example, or some point. And they're going to come up with a mathematical model to represent the location of the sun, the azimuth, and the altitude as a function of where they are located, which is denoted in both time and space, which will be their location, longitude, and latitude, or whatever grid system they want to use. It doesn't have to be that. Whatever location system they want to use, total freedom, as well as the date and time, okay? But this is, so everyone's going to have to formulate a mathematical model. This process, I believe, unfortunately, the educational system is only known by about 5 or 10% of the population. And within that 5 or 10%, very few people even know math anymore. So this is unfortunate, and our goal of our event here is to really awaken people to this and to emphasize the need for people to understand math and build this. The next is an experiment takes place. In the experiment, this hypothesis will be tested, okay? And the hypothesis will be tested by running an experiment. The experiment, whatever that is, will gather these 3 variables, M and A, let's say the inputs, and F, the output. And the data will be gathered. It'll get organized. So for example, here, if I organize it into a table, force, mass, and acceleration, the first column being force, mass, and acceleration. And when you organize the data, now you look at it and you say, what does this data reveal? This data reveals F is actually equal to ma. It's not ma squared. Therefore, your hypothesis was wrong, and this is the actual result. So you would go back and you say, well, I'm wrong. This is the actual reality, what nature or the actual data is showing. So you would come back and say, this is wrong. F equals ma, which in fact is true by Newton's laws, right? But this is a scientific method. And once you get the results, you have to own up to the reality. If the results match with the model, then you can say the hypothesis was accepted, you've discovered something new, or you've asserted your hypothesis. If it's not, you have to reject it. Okay? This is a scientific method. And we played Richard Feynman's video. And the reality is that either the scientific method is right or it's wrong. I mean, either your answer is right, and if the results, if they're right, if they match with the model, you're correct or you're wrong, okay? It's that simple. So today, there are two potential experiments on the table. One is, as I mentioned, where is the sun? Defined by the azimuth and the altitude, which would be essentially the outputs. And the inputs are going to be pretty complex, and people are going to have to give their assumptions. All right, so we did that. And the other important thing that we want to emphasize is that if this is in fact true, F equals ma, this is every time you do this, you're going to get reproducible predictions. That is evidence. So the evidence is the models that people are going to propose today in flat Earth and round Earth, relative to the Earth's location or the airplane experiment, that's going to give us a model. And if every time that model gives us a reproducible prediction or predictions, that means it's evidence of either the Earth being round or flat. That is science. All right. We also talked about, to those people who think this is a very real example of billions of dollars went into the climate change concept that the Earth, the Arctic ice is going to melt tomorrow. And it was based on a hypothesis. And scientists associated with the IPCC built 100 different models asserting this. And if you look at this graph, this is by year. The y-axis is how much ice is going to be melted, okay? And what you find is every line here represents a different mathematical model. Notice you're getting 0 ice being melted by this model to all the ice being melted by this model. This is not evidence. You would at least have all of them converging on the same answer, and they don't. So this is not evidence, and this is why the entire quote-unquote climate change stuff is just garbage. But yet, people who have no scientific understanding, and even with people with scientific understanding, because there's a lot of money behind this, are promoting this. All right? So what we're doing is a serious service, and that's why I decided to take this on, the flat Earth, round Earth thing, to really educate people on the fact that this approach is not being used anymore, and even at the highest levels of academia or the lowest levels of the grifter class, they're both violating this. And it's all being done either for money or for influence and to take advantage of people's stupidity. And I think we don't want to allow that. But this is what a model is simple. Today, we're going to look at each group is going to share with us what their inputs to their model are and what the output is. In the case of the Earth, the output is going to be 2 numbers, the azimuth and the altitude. The input is going to be the location of the individual in whatever grid system people want to use, and the date and time. And then one thing that's missing here is people should also share their assumptions, as we talked about, because we don't want the round earthers using flat. If the Earth is in fact flat, the round earthers could manipulate their data by using flat Earth assumptions in their model. Similarly, if the Earth is in fact round, the flat earthers could round Earth assumptions to make their data look good, and that would be cheating. So we're going to be very, very circumspect on the assumptions. Okay, so that's what we discussed last time. And
can you say that again with what is cheating? I didn't get it.
Well, for example, if the Earth, let's assume the Earth is flat, right?
Acoustically, I didn't hear it. Just repeat it, yeah.
If the Earth is flat, the round earthers could manipulate their model by using embedded in their model would be variables that in fact the Earth is flat that they could use. Similarly, if the Earth is round, the flat earthers could, in their equations, use round Earth data, round Earth variables.
You got your script. Okay, yeah. Mhm.
What's that?
No, it's okay. I got it now.
What did you say? What script?
Am I well to hear?
I didn't
No.
understand. Can you guys not hear me?
I can hear
Do
you.
you hear me well?
Yeah. Do you understand that?
Yeah. I heard this just before. I heard this before, so I know what you're talking about. Yeah.
Okay. Does everyone understand what I'm saying? Round Earth and flat Earth. So both you guys have to share with us how you're coming across with your models. Typically, a model has the variables, what assumptions that you're making. Okay? We don't want any deception here. Okay. So there we go. So as a part of what we discussed was one of the experiments, let's go back to this, was the notion of if you're looking out your window, there's an X and Y point on an X and Y axis, and the sun is going to be at a certain location. Can you guys see this or no? The globe earthers are going to take position in time, and they're going to output X1, Y1 for that location. And this could be anywhere. Same with the flat earthers. That was one experiment. And then we'll go into the other experiment was proposed by the flat earthers, which is you have an airplane flying into an ILS tower, and the height of that airplane, as I think we said, was 6,355 feet. At that point, if the Earth is flat, the nautical miles will be 23, and in this case, the nautical miles will be 21.75 if it's round. However, a very good discussion took place on the error margin, and we agreed that the model for this must include the error margin, because if the error is within, between 21, which is, this is roughly what, 2 miles or 1.25 miles, right? Then it's basically meaningless and nonsensical. So the error margin must,
yeah.
What was that?
That we get to that point. Is my audio too low?
No, let me finish. Please don't interrupt. I'm just presenting, and then we'll go. Okay. So for this experiment, that model also needs to be included. All right. So that's where we left off. So today we're going to go with. Let me go back to Zoom. We're going to go to the globe Earth model, or the globe Earth, the sun experiment, and the globe earthers will present their hypothesis, and their mathematical model. And the mathematical model, again, will take the variables of the location. So I'm looking out my window, my location, whatever grid system you want, the date and time, and the output of that equation should be the azimuth and the altitude. So who on the globe Earth side is presenting this model?
Let me guess.
I will be.
Who's that?
Dan.
Oh, Dan. Was that your guess, Kevin?
No.
Did you get it right? You win a prize.
Oh, so
Okay.
he got introduced, yeah.
Okay. Before we go, just very briefly, because for the new people, if people can just do a 2-second or 5-second introduction of each person. Dan, do you want to introduce yourself briefly? And then we'll go to Kevin, then Ryan, and Dr. Prabhakar, and then Mike. Go ahead, Dan.
My name's Dan. I run the YouTube channel called Unfornicated, where we do science communication and as well as a couple other projects to kind to break up the monotony of conspiracy theories that we also debunk. My background is specifically started in the military and supporting signals intelligence by operating and maintaining radio and satellite communication networks. And then I transferred that into a telecommunications career as a network engineer for the past 25 years.
Thanks, Dan. Let's go to Kevin.
Yeah, I studied media management. I did an online course about how money is fraud and how we could have alternative money systems. Down the rabbit hole, I saw too far on one vacation, and I dug down this rabbit hole, and I did lots of experiments. For example, forced the fishing line below water. And I heard your interview with Dave that you want to agree on one experiment, and I joined the discussion.
Great to have you, Kevin. Let's go over to Dr. Prabhakar Dinakar.
Hello, this is Prabhakar. I am a systems biologist, and I am on the global side for this discussion.
Just what's your background, Prabhakar?
So I trained as a chemical engineer, and I did my doctoral studies in biomedical engineering. And I am also passionate about science education, and that's why I'm interested in this debate.
Great. Okay. Let's go to Ryan Shea.
Hi, Ryan Shea. I'm in Dallas, Texas. So how I got involved in this is just I'm a flat earther, and many years ago now, someone brought up when I was in a tall building, like, it seems like we can see too far here, doesn't it? And I thought about that and started wondering and started looking at this deeper and started doing my own experiments, light tests, laser tests, just observations, more study. And so here I am. Appreciate you having me, and thank you for everything that you've done to put this on. So thanks.
Thanks, Ryan. And then we go to, is it Mike? Mike there?
Yeah.
Go ahead, Mike. You're on mute. Go ahead.
Yeah. I'm Michael Toon. I studied electrical engineering and computer science at university. I have been a professional software engineer for my career. So I got the science background to address this topic. I've been debating flat earthers online for about 7.5 years. 7 years or a little more, I've had my YouTube channel, MCToon Live, and I have another one where I do just pre-recorded videos called Conspiracy Tunes. And so I've been involved and interested in this for a good long time. And so thanks a lot.
All right. And is there anyone else? We have and I guess there's a guy called Bobby who hasn't shown up. So his name, I think his code name is Globe Slayer. And he's also done apparently some experiments in different areas, but he's not here. So we'll just start. So let's go to Dan. Dan, can you, on the Globert side, represent the mathematical model, aka the hypothesis, because you're proposing the Earth is round. We have the sun experiment. Can you share the mathematics, if you can begin with your assumptions?
Yeah, it says sharing's not turned on.
Oh, Prabhakar, I think, can you make Dan?
There it is. Now it is.
Yeah,
Okay.
I did.
Okay, go ahead, Dan.
Okay, so basically, this is a solar position calculation and verification experiment. It's a ground-based, reproducible method for determining solar altitude and azimuth from anywhere on the globe. So the purposes of this is basically to show how solar position is calculated. We need to show the full prediction workflow, demonstrate how anyone can verify the results. We're going to present a real location example, starting with the MIT campus at Killian Court, which is right outside the library, and provide a rigorous and repeatable measurement procedure. So what are we actually calculating? We're calculating the altitude, which is how many degrees above the horizon. 0 degrees is the horizon, 90 degrees is straight up, or what we call the zenith. the azimuth, which is what compass direction. So 0 degrees is north, 90 degrees is east, 180 is west, and so forth. So what information do we need to do this? Well, we need the date, like what day of the year. That's primarily due to the individual where we are in the orbit, as well as the tilt of the Earth in that orbit that creates the geometric impossibility of how to predict this. We need a latitude to know how far in south you are. We need a longitude to see how far east and west you are. And we need to know what local time to use. So in this case, what we're going to use is, like I said, we're going to use Killian Court at MIT campus in Cambridge. We're going to use today, and we're going to use 1400 hours or 2 p.m. local time. The reason why I decided to do this is because Dr. Shiva can actually confirm this while we're on the call. So what is the end result going to be? Well, we're going to walk you through our piece of this, but the end result's going to be, the altitude will be at 19.4 degrees, and the azimuth will be at 217.7 degrees south by southwest. So how are we going to verify these predictions yourself? Again, this is kind of an open call for anybody who's watching these videos to do this and also be able to provide the same predictions going forward, that it's not just me that's able to do this. So we need some requirements, GPS position, plus or minus 1 kilometer. This is where we start getting the error margins. We need time plus or, accurate timing, which is plus or minus 30 seconds. We need an altitude angle of plus or minus 1 degree minimum. Smartphone apps are typically between 1 and 2 degrees. That's actually going to be our overall margin of error for this experiment. And the azimuth angle is plus or minus 1 after magnetic declination correction. Keep in mind that this predictive model is based on referencing of true north, not magnetic north. So if you're using magnetic compass, you need to account for the magnetic declination correction. So why does this matter? Well, we're using terrestrial experiments, no satellites, no spacecraft, no appeal to NASA, no appeal to authority. This can be verified independently, so no trusting authorities again. The test is repeatable by anyone, anywhere. Doesn't matter if you're in Northern Hemisphere, Southern Hemisphere, what continent you're on, this should still apply. And these predictions have masked observations consistently across centuries of measurements, and this includes maritime celestial navigation that's been done for hundreds of years, whether they were English, Portuguese, Spanish, French, American. So let's get into the quick assumptions. These are the important assumptions, and this is basically how we frame our model. Assumption number 1 is the Earth is a sphere. Now, each one of these assumptions is going to be based on empirical evidence listed at the end as far as our sources go. We've known that the Earth is a sphere for roughly 2,000 years, and we've had various different experiments that have continued on to show this, from Eratosthenes to all the way to common things with radar and radio horizons. We're going to use a simplified solar declination formula. As part of this experiment, there is a method that uses a lot more intrinsic math and derivatives to create something that is 0.00003 degrees accurate. Well, since the devices that we're using as smartphones, it's not necessarily go that far. So we're going to use a simplified version that gives us between 1 degree in error margin. We're going to be ignoring atmospheric refraction because what we're going to be doing, specifically in this example, is using above 10 degrees altitude. We'll come back to that in a moment. I'll explain that a little more. The other assumption is that the sun is infinitely far away, and therefore it's near parallel rays. The divergence is actually 0.0025 degrees. It's negligible. And we know the distances to the sun through parallax measurements, as well as terrestrial bound radar that bounced a radar signal in 1967 off of the corona of the sun and back, and we're able to verify that distance. We're ignoring nutation and precession. These are slight wobbles that are basically large scale, and they take a lot of time to take into consideration. Again, the amount of difference error margin on a day-to-day basis is negligible. And we're also taking depth observers at sea level. When we get to higher altitudes, there'll be another somewhat correction. But again, because of what we're using right here in Cambridge, this is kind of what we're looking at. And primarily, we want to kind of do this near water, so that way there's no obstruction, so to speak. So the bottom line assumptions is that the total combined error of these simplifications together typically produce errors about 1 degree. Like I said, there's other precise algorithms that go further. We use a model that's accurate enough for the question we're asking. For practical solar predictions, our simplified formulas are much more than sufficient without getting too deep into the actual math and implying more advanced math than what maybe common people have access to. Every assumption listed can be verified using terrestrial ground-based observations. Again, no satellites, no spacecraft, no trusted space agencies. The measurements have been replicated independently across centuries and cultures. Based on these assumptions, the margin of error for this experiment are plus or minus 1 degree for the sun when it's 10 degrees above the horizon or more, and 2 degrees for the sun when it's below 10 degrees above the horizon. That's going to be times of sunrise and sunset. So solar declination. Solar declination is the angle between the sun and the Earth's equator. Think of it as how far north to south the sun appears to be when you look at it from space. The sun makes an analemma. It's like a figure 8 that as it progresses from the Tropic of Cancer over the equator to the Tropic of Capricorn. That's where the apparent location of the sun is on Earth. Now, why does this happen? Because Earth's axis is tilted at 23.5 degrees. So the formula for this is going to be delta equals negative 23.45 degrees times the cosine of 360 divided by 365 times d, which is the day-to-day, plus 10. Now, what this is this is going to be your solar declination. D is the day of the year. So January 1st is 1. December 31st is going to be, oops, I'm sorry. December 31st will be 365. So for today, we're using 319 for November 15th. The axial tilt is 23.45 degrees. And how many degrees Earth moves in its orbit per day is going to be basically, the orbit is 360 degrees. We divide that by 365 days, which is the entire orbit for the year. And because it creates a sine wave, we're doing plus 10 because that's the adjustment, because the winter solstice happens around day 355, not day 0. So
Dan, can you
this
just
formula basically comes from watching Earth from space as it orbits the sun. The sun's position is relative to Earth's equator, and it follows a sine wave pattern. So we are using a cosine function with the amplitude, which is 23.45, and the period, which is our orbit of 365 days. This perfectly describes what the Earth does based on our assumptions. We use cosine instead of sine and add the plus 10, again, to align the formula with the actual dates of the solstices. So in our example calculation for November 15th, here's all the math that goes through this. It just means that on November 15th, the sun is roughly 19 degrees south of the equator, halfway between the equinox, which is the equator, and the winter solstice, which is the Tropic of Capricorn at 23.5 degrees. Next thing we need is the equation of time. So the equation of time tells us the difference between solar time, which is the time based on actual sun position, and mean time. So just because it's noon on your clock does not mean that's the highest point that the sun is above your head. Two reasons for this is Earth's orbit is elliptical, not circular, and because we're tilted. So this is the formula here. Basically, we have 9.87 times sine 2b minus 5. I'm not going to read all these equations. Here's the equation here, where b, you would substitute this equation here, which is what we did previously. So this includes the day of the year, and the equation of time basically uses a helper angle to help to track the Earth's position in orbit. Now, a surprising fact of this, like I mentioned, is that solar noon isn't always at 12 o'clock, depending. Sometimes it's a few minutes early, sometimes it's a few minutes late. The equation of time tells us the difference between these two. So this is derived from the 9.87 times sine 2b term captures the effect of Earth's axial tilt, and the negative 7.53 times cosine b, and the 1.5 times sine b captures the elliptical orbit. So this minus 81 offset aligns the formula with the spring equinox, which is around March 21st, or day 8. So basically, this is a Fourier series approximation. So since it's a periodicity, we're using sine and cosine waves to approximate a complex periodic function. The full calculation used by astronomers are many more terms, but these terms get us within 1 minute of the true value. And here's our example calculation for here. So if we start here with November 15th, and we multiply that by the axial tilt variables and the orbital variables, we at 234.7 degrees. We now include that into our equation, and our equation comes all the way down to, we are at plus 14.88 minutes. So this means on November 15th, solar noon happens about 15 minutes after 12 p.m. mean time or local time. This positive sign means solar time is behind clock time. Now we need to do another little correction called longitude correction. So longitude correction basically applies for every time zone has a median longitudinal line. So in the Eastern time zone, it's 75 degrees west. Now, since if you're on one side of that, if you're right on the meridian, there is no correction. However, if you're on either side of the meridian, if you're east of center, solar time comes earlier. If you're west of center, solar time comes later. And that's just the path of the sun across the sky. So the formula for this is 4 times your local longitude minus your standard meridian, and the correction is also in minutes. So for this one, specifically, since we're using MIT, it's negative 71.09. So we do the subtraction, do the math, do the multiplication, and we end up with 15 minutes. This means that MIT is about 4 degrees east of Eastern time zone central meridian of 75 degrees west. So solar noon happens about 16 minutes later than the standard 12 o'clock. Now we need to talk about hour angle. So the hour angle tells us how far the Earth has rotated since solar noon. This is the sun's position across its daily arc of the sky. So since we're 15 minutes later, we need to account for that. So solar noon is at 0 degrees, morning is at negative 45, positive is plus 45 is the afternoon, and sunset would be 90 degrees. So this is the formula where we insert the variable TST, local time, so that we derive it based on EOT and our longitude correction divided by 60, and then we multiply it by 15 degrees per hour. So in our sample calculation, we are seeing an H value of 37.63 degrees. This means at 2 o'clock p.m. time in Boston or MIT, Cambridge, the sun is 37.63 degrees past solar noon, or about 2 hours, 30 minutes past its highest point. So now we have all our variables. Now what do we know? We have a declination of 19 degrees. We have an hour angle of 37 degrees. We have a latitude of 42.36 degrees. We can finally calculate where to look in the sky. Now we need to use spherical trigonometry because our assumption is the Earth is a sphere. So the altitude formula, we're using 2 different formulas here. So the altitude tells us how high the sun is above the horizon. So we're using a 2D coordinate system, so we need the X and Y axis. So altitude is our Y axis. We are basically, to imagine this, imagine 3 points. We have the North Pole, which is 90 degrees latitude. We have our location in Boston, which is 42 degrees north latitude, and the sun's position, which is a declination of 19 degrees, and hour angle of 37 degrees. These 3 points form a spherical triangle on Earth's surface, and the altitude formula comes from the law of cosines for spherical triangles. So basically, this means that we apply this to determine what all the variables in. So we insert our variables to get our variable, which is going to be here for the altitude. So after substituting and using trig, basically we come with an altitude of 19.43 degrees. That's what it's going to be at 2 p.m. at MIT and Killian Court. Now, the azimuth formula, this is your x variables. So this is your x-axis. So this is going to be using the law of sines instead of cosines. So we do have a special rule for this. If your H hour is greater than 0, meaning it's afternoon, you have to subtract 360 from that value. Otherwise, you can just use the value. That's just because of 0 now becomes a negative number. So this comes from the exact thing we talked about previously: North Pole, Boston, sun's position, all have basically a central points that create a spherical triangle. And specifically, we use the law of sines in this case for spherical triangles. Now we're going to be getting the variable here, which is going to be B. So MIT at 2 o'clock, here's our variables that goes across. So we have the theta of 4236, we have the delta 1992, we have the H value of 37.63. We insert that all through this wonderful math equation for law of sines, and we come out with A equals 42.3. Now, since our H value was higher than 0, because it's 37 degrees, now we subtract 360 from this measurement, from this azimuth measurement. This means the sun's azimuth will be at 217.7 degrees true north. Now we're going to touch very quickly on refraction. When sunlight enters the atmosphere, it bends, it refracts because atmosphere density decreases with altitude. As you look across to the horizon, you're looking through more atmosphere than you are looking straight up. So while our error margin is basically going to be plus or minus 1 degree at the when the sun is more than 10% or 10 degrees above the horizon, it'll be 2 degrees in that, because just refraction alone will add 1 degree margin of error, and that is basically the perceived shape and position versus the actual position from what you're seeing. This is a formula that we use to determine refraction. Again, we're not applying it for this case. However, should someone want to do this for sunrise or sunset, we can absolutely attribute this. So let's put it all together. We have the solar declination, we have the equipment of time, we have the longitude, we have the hour angle, and we put this all together. So that means, as we discussed, at 2 p.m. on November 15th in Boston, Massachusetts, or Cambridge, Massachusetts, at MIT Killian Court, the sun is 19.43 degrees above the horizon as an azimuth of 217.7 degrees true, not magnetic. These work because solar declination varies because the Earth's axis is tilted relative to this plane. The equation of time exists because Earth's orbit is elliptical and its axis is tilted. And the longitude corrections work because time zones are based on a central meridian on a rotating sphere. The altitude and azimuth formulas are spherical trigonometry. They literally cannot be derived on a flat plane. So we have a challenge to verify this. The test is a 3-city challenge. And I have people in Houston and Uruguay, and 2 of these cities, to actually already agree to this. On December 21st at 2100 hours UTC, which is going to be 9 o'clock at night, in Houston, Texas at 3 p.m. local time, in Lima, Peru at 16 p.m. local time, and Uruguay at 6 p.m. local time. Everyone does a measurement. Everyone goes out and does this at that local time. And what our predictions are going to be is that the altitude will be here. It'll vary. The azimuth will be here. All 3 will be verified. But here's the part that should be driven home: is the direction of the sun from these 3 locations. All of them will be towards the south. So whether it's southwest direct or west-southwest in the southern hemisphere, it's still going south, not north. So these are our predictions. What are your predictions? Show your math, and we'll be back here on December 22nd, and we can compare. So my sources, basically, there's empirical sources. There's also other sources and experiments that have been done. But for instance, the oblate spheroid, we talk about the Department of Defense geodetic system. This defines the WGS 84 reference ellipsoid, says the radius at the equator is going to be somewhat larger than the polar radius because of the flattening at the poles. Solar distance and parallax. I talked about the radar that we did. That was done in 1967 by, I believe it was done by MIT, actually. And we also have the International Astronomical Union, in which case they had defined an astronomical unit of length, which is the distance between Earth to the sun. And they defined it exactly as that number, which I'm not going to read off. Nutation and precession, which we ignored, but if you want to look at it, there are some other things here. Solar position calculations, there are a couple of different algorithms that can be used outside of mine. Mine are based on a couple of these. Again, the NREL will provide you with 0.0003% accuracy. However, for that to ensure that sort of accuracy, to verify it, you are going to have to use a theodolite. Standard refraction values, this is based on U.S. Naval Observatory and NOAA global monitoring, and there's additional resources here. And that is basically the presentation.
Mike, very briefly, can you just, and then we're going to go to the flat Earth.
Oh, I can actually show the calculator itself. That would probably be beneficial.
Yeah, but just to, by the way, thank you very much. Very nicely organized presentation. But there is a formula, right? Mm-hmm. And the formula is the input is the day of the year. You're
Correct.
using longitude and latitude.
Right.
And the local time and the time zone. And the output, which is in row 19 and 20, is going to be the solar altitude and the solar.
Correct.
And that's what we asked for. And your calculations are based on various assumptions inside the guts of your model. You're calculating the solar declination, equation of time, et cetera.
Correct.
But if you can just go to Peru, those three examples. So Mike has proposed, per the scientific method, a very clear, cogent mathematical model. And based on his mathematical model, he's predicting, if you go to that slide, that at these, by the way,
hey,
if you can go to that.
Dan is proposing it, not Mike.
Yeah,
Dan.
sorry, it's Dan, not Mike.
Yeah.
Yeah, sorry, Dan. No. The Peru, those three cases, Mike. Sorry, Dan.
Oh, you're talking about the three cities?
Yeah. So basically, per the scientific method, Dan has proposed a model, so he's done that. He's shown the input and the outputs. And then per that model, if the evidence is that the Earth is in fact round, then the reproducible predictions are, drum roll, can you bring that slide up, Dan?
It's up right now, isn't it?
Dan, you're sharing your desktop, or maybe just
You're sharing your desktop.
I'm sorry, hold on.
Yeah.
Let me share this, sorry.
Right. So per Dan, he has a model, and he's proposing that these will be the reproducible predictions.
Sorry.
I got it. Oh.
I changed this because I had somebody in this town, so.
Okay, you're good.
Sorry.
Yeah. So, but basically, if in those locations, obviously there's an input, right? Particular date,
Correct.
time you have, which I think you said was December 21st, right?
Yes, December 21st, 2100 UTC.
Right. So those people in those locations are going to tell you and us where the sun is. If your view that the Earth is round is true, then the sun in all those three locations must be those specific altitude and azimuth pairs in those three areas.
Right, and also in the southern half of the
southern half. Yep. All right. All right. Great. So, basically, any questions that there's a model that is based on the Earth being a sphere, there are predictions that are made, and if those predictions are true, then that is evidence that the Earth is round. Okay?
Well, Here's the thing. Toon was in Antarctica on a specific day.
Yeah.
So we can also verify this based off of his measurements that he made at Union Glacier.
Yeah. Well, the other thing is, I think anyone listening, I did this many, many years ago, but if you just go on the internet and you say, give me the position of the sun, there are various points that, and I propose, Dan, you have maybe the opposing team will say these three people that you're choosing may be friends of yours, but they're independent data points that you get in real time.
Right.
If someone just wants to search online as we're doing this, you'll find those points. There's actually points, I think, all over the world, India, Argentina, that they're actually looking at where the sun's position is. And you know the location of those measuring devices, the longitude and latitude. So we could theoretically do this right now.
Yeah.
If you wanted to, right? You could, if you wanted to do that, Dan, you could plug in your formula, find those locations right now. And then once we get the flat Earth formula, we could do that. So if someone online wants to send those links to us, but there are a number of places all over the globe that you can actually measure the azimuth and the altitude of the sun in real time.
So just as an aside, I touched on this briefly, but it's something I think I just want to reiterate, is that you can download a theodolite application app for your phone. And then once you download it and calibrate it and things like that, that is what you can use to measure this. You don't need a theodolite, you don't need a total station, you don't need a sextant, although all those do work. For something as simplistic that anybody can use, you can get a theodolite app on your phone.
Is there an app on your iPhone that tells you?
Yeah, Mike has one, I believe.
Yeah.
I see.
Yeah, on iPhone, it's called Theodolite. It's about $3. On Android, there's a couple different ones. The one that I used to recommend isn't on the App Store anymore, so I don't know just offhand what Android one is.
Yeah, I can only speak to the iPhone.
Okay. So can you put that in your presentation, Mike? But what I'm saying is, independent of these iPhones, there's actually ground-based data feeds. Is there not? I mean, let's see if I can find one.
Well, yes. I mean, there's internet ones that you can actually verify this too. If you want to go to like suncalc.org and things like that. I mean, I can pull these up if we wanted to, because I can actually use this exact example here and show what our margin of error is based off of suncalc, which is what like it's one of the ones that the meteorologists do for determining sunrise, sunset, and things like that.
Okay. All right. All right, let's go to, is there anything else you want to share?
No, I wanted to go to, you said to add this to the thing as far as tools goes. So what are we calculating? And I want to add to app this, but yeah, I can stop sharing and then I can go to, we can go to somebody else.
Okay, bottom line is you have proposed 3 places on the Earth with people that you have, and you have a prediction per your hypothesis, and then you're willing to put your butt on the ground on December 21st with your people to measure this. If those numbers are right, you have evidence that the Earth is round.
I mean, I'm willing to go to Uruguay. I mean, I could always go for a trip somewhere south and warm in the wintertime. I'm all for that.
Yeah. All right. The bottom line is anyone can do this. Wherever you are, if you can get one of these programs, you can, maybe Mike, maybe this, we're going to have a website for this. Maybe we can just put an app there where it just runs it, you know? Right off the internet, the Institute's website.
And I'll check the Google Play to see what the Android one is based on of large errors.
Okay. Yeah, so we could put this right up on the website. Anyone can type in their location where they are, and it'll say where the sun is going to be, and then you can measure it by yourself.
Correct.
All right, fantastic. So let's get a similar or a different, but the same approach by the Flat Earth team. And who's going to present there? think we need to unmute
Yes,
Kevin and
yes, I'm
Brian.
here. Now it's fine, yeah.
All right, so go ahead, Kevin. Do you need to share your screen?
Of course, yeah.
Prabhakar, does he have sharing rights? Okay.
Is it big screen now?
Yeah, I see it blank. Oh, now I see it. Go ahead.
Okay, so in order to present math for a flat Earth's sun, I could go to Bislin's model. Notice the conditional tense that I could do it. The sun is rising and setting via perspective on the azimuthal grid of vision. We could go, again, the conditional tense, to the source code and extract the formulas from there and show the coordinate system transfers. And we couldn't agree on who was first, because you said I couldn't use your formulas, your distances, and you would say you couldn't use mine. But some first things that goes against this model, and I will continue with the values. We don't expect the sun to behave as solid object. We don't assume the dynamic mechanism. So we don't know the dynamic mechanism. It could be magnetism involved. And we don't assume the position of the actual sun. It could be more, we don't know where it is exactly. We only have the visible sun. So it could be a parabolic reflecting sun somewhere involved, or as I said, magnetism play a role, as we see in the torus field. So our hypothesis is that our vision isn't Euclidic, but visually curved. So lights in the sky doesn't rise or set via Earth curve, but by perspective. It could be one reason. And that we see not only the sun rising or setting or alleged objects, or let's rather say lights in the sky rise and set, but we see rays above us rising and setting, indicates to this factor, to this hypothesis, because it's not only a light in the sky, but the whole sky. Papers which suggest this is the direct measurement of curvature of visual space, for example. So it is deeply in question whether we see in Euclidean space all the assumptions that you have to make for your angles, and that you assume the globe only. You would need to see straight, but you see down here, it's certainly not Euclidean. It's at best, it's
Yeah, so one second.
it's a question, but wait, one question, one thing I let you
No, 1 second. Kevin?
Presentation.
Kevin.
I will present the formula. I presented one formula. I don't know why it's already starting like this, that he could speak.
No, I just wanted to make sure that the goal is, this is not a debate. It's not the globe Earth people are not saying anything about flat Earth. You're starting off by talking about the globe Earth model being invalid. The goal was, please present your assumptions about flat and then derive your model.
Look at the hypothesis here.
Yeah, so what your assumptions?
It's a flat ground and visual curved. So for the kinematic,
so what is your
for the kinematics? It's for the perspective sun. This model is pretty accurate for only the kinematic part.
Can you just hold it there? Can you just hold it there? So you're saying the Earth is a round, flat dish. Is that what you're saying?
No, I don't assume the ground, and let me please speak, make my...
Yeah, I just want to know what your
I didn't
assumption is.
interject. I didn't interject at all. You have to interject me already for as
Right,
I
because
could
you were
let you
going
speak
off
20
attacking-
minutes. I didn't attack. I showed this torus field where the sun could go to the outside. It's not helping when you cannot make let me read my points of the variables. So you said that we can bring 10 people, our best, the top 10. You said here, top 10 people we can bring. So you know that I'm not the best guy for this. There are a lot of this. And you said we have to agree to one experiment, and I just want to share where you said this.
Okay, wait a second. What the fuck are you doing right now?
I will.
Stop.
We have to agree to one
stop.
experiment, and that's where I.
No, stop. Please mute him because he's fucking around. Dave was given that opportunity back in early June, and he never followed up on it. He was supposed to set time with my assistant. That nullified it. Now you're going back to try to attack my credibility, Kevin, and your people, Dave's people, never followed through. In fact, Dave was invited and he never followed through. Now follow with the agenda. What is your assumptions? What is your assumptions about flat, and show us your model? Okay? Are you going to do that? That's the agenda. Your boy Dave never followed through. Okay, are you going to show us your model? If you're not, we can end this discussion with you because you're bullshitting once again. Are you going to show us your model? Can you unmute him? Can he unmute it, Barakar?
Yeah, I asked him to unmute.
If you're going to talk about Dave, then I will take the position, I will expose Dave for what the fuck he is. You're supposed to present your assumptions about flat Earth and derive the fucking mathematical model. Do you have the model, yes or no? Show the fucking model.
Unmute yourself, Kevin, and you can share your model.
I'm not going to let you derail this because that's a deception. And that's what you guys have been doing. But then do the fucking work. Show the model. Period. Show your model.
Myself. Now I can finally speak.
Show your assumptions in the model.
Christ.
Show your assumptions in the model.
So I'm not allowed to speak anything against your.
No, because you're lying, and that's a different discussion.
I'm not lying.
This is what the fuck you do. You deceive. Show the fucking model.
I speak
That's what you agreed to do. Bullshit.
Objections.
Show the fucking model.
Wait, where is it?
Show the model. Not going to let you derail it.
Sun observation refutation. This is
show us your assumptions of your model.
So if this mathematical model is able to predict that observation, then you have evidence that the Earth is flat or the Earth is round. This is not logically true.
You're not sharing your screen, Kevin.
Your prediction is actually instead a post-diction.
We don't see your screen.
Oh.
Start with the assumptions. Show us the derivation of your model. That's called science.
You stopped my screen share.
I didn't stop anything. No bullshitting.
So make it big screen.
Yeah, so show us the assumptions and the mathematical derivation of your model for predicting the sun, assuming the Earth is flat. Go ahead.
I have to say that only because one model is adjusted for one or several phenomena, assuming lots of uncontrolled variables, that's not a definitive falsification process for other models. We have long lat computing, 1% is only measured for the system. We could use, everyone could use, and you from the beginning said FMA is an example has clear variables, the f equals ma, because there's an object, but we don't know the object here, and I have to speak as opposing party here that I didn't agree from the beginning to do this as a definitive thing to determine the shape of the Earth, and that is what I would suggest. So you do the
What are your
with this
assumptions
thing.
of your flat Earth model?
We are affirming the consequence. If the Earth is a globe, for example, you say, then there is a 24-hour sun in Antarctica. If there is a 24-hour sun...
Wait, stop. You're not following the instructions. Stop. You're like a fucking 2-year-old. What is the instructions were what you agreed to? You would come to this meeting with the assumptions of flat Earth and derive a model. All you're doing is you're attacking the globe model. Bullshit. I'm not going to let you do that in this forum. You guys have been fucking doing this for ad infinitum. Where is your assumptions of flat Earth and derive your model? Period. Are you going to do that or not? Are you capable of doing that? If you're not, you should get out of this fucking game.
I'm not the right guy to show the models. It will be Shane here.
We gave you guys a week.
Alan Space Audits. You can use him. Stop. I show you this model. Okay, you will see this model.
Time out. Time out.
Look at this model.
Please mute him.
I show this model now.
By the game. He's not playing by the rules. Please mute this fucking guy. Same deception.
I can give brief info on that model he's showing right now.
Wait a second, Mike. Rules were set in place from day one in 2 pre-meetings. Dave Weiss was invited. The fucking guy chickened out and ran away because he's full of shit. So we decided that we would follow the scientific method. We agreed. Yeah, you would come up with the assumptions today and the model, and you're not doing that. So either you don't have it or you're bullshitting. I'm not going to let you waste my time, my family's time, with your fucking bullshit. Do you have the goddamn model? Yes or no? Do you have a mathematical equation, Kevin? Yes or no? Do you? Do you have a mathematical equation for predicting the sun and the airplane for both things using a mathematical model? Yes or no?
The airplane, I have a lot to say still, yes. But
No. For 2, everyone, I started this forum, and we've been talking about this over 2 weeks. Do you have the mathematical model for assuming the Earth is flat, for predicting the sun's location? It's a yes or no question.
Yes, I show the
okay, so show us
derivation of the derivation of the radius.
Do you have the model for the location of the sun?
I can show
assuming
you.
It's
You
flat.
see my screen?
Yeah, but I'm asking you a question. You're not answering the question. I don't want to go forward if you're not going to show us a model of the prediction of the sun, assuming the Earth is flat. Are you going to show that, like Dan did for the round Earth? Yes or no?
I show this Bislin model for kinematically equivalent.
I'm not asking that. You see how hard it is to get an answer out of you?
No, I'm answering.
Do you have the model of predicting where the location of the sun is using whatever grid system you want, assuming in your view the Earth is flat? Do you have a model that you can tell me, or Ryan, or Suresh, or Dan, or anyone in the world where the sun's location is going to be if the Earth is flat? Do you have that mathematical predictive model? Yes or no?
We have this radius derivation of your vision. Why the sun?
No. You're not answering the question.
I'm answering.
No. Now I'm going to.
I can't bring a sentence.
Does anyone else understand the question here I'm asking him? This is why we're doing this whole forum, and it looks like you don't have it.
I'm shut down. I'm shut down.
No, it looks like you don't have it. And if you don't have it,
I've showed 3 variables here.
Do you have a mathematical model for the 15th time that if you could put my location in a date and time, and assuming the Earth is flat, you will tell me where the sun is? Yes or no?
your prediction of a model is not. It doesn't show anything about the shape of the Earth just because you want to mathematically.
I'm not asking you. I'm asking you. We gave you full freedom to define.
Yeah, you have hundreds of years. You have hundreds of years.
You're not
long
answering
and
the
last.
question. Listen, you're not answering the fucking question. Do you think I'm a fucking idiot? You've been dealing with fucking idiots and you're taking advantage of people.
No,
Assuming the Earth
I
is
never
flat-
earned
assuming
anything.
the Earth is flat, tell me your fucking mathematical model. Do you understand that?
Look at this diffraction and the derivation from the
Do you
wavelength
have
of
the
the eye
mathematical model?
and go to
Do you
James
have the
and here he will
mathematical
explain
model?
it to you exactly.
You have the
Very good.
mathematical model, yes or no?
Space audits and
Do you have-
Manstone, go to them
Yeah.
and you see it here on
Yeah.
screen. I just
I don't
don't
give a
want to
fuck who they
defend
are.
it.
Do you have a
I don't want to
mathematical
defend
model?
it.
Do you have a mathematical model, Kevin, of the location of the sun, if assuming the Earth is flat? If not, I can derive it for you. And you can tell me if you don't know how to do the math, because you clearly have a bunch of retards who are helping you or not helping you.
No, I don't have a model myself.
Okay, so you
no.
don't have it, you fucking lose.
Okay,
You're done.
so let's go to the
You're
next one
done.
then.
No, you're
Fine,
done.
You can go to our.
No, it's
to the
over.
hour.
It's over.
Go-
It's fucking
go to
over.
the other.
We're gonna
Okay,
end this.
Do it. No,
It's over.
I want. You
It's
know
over.
exactly that our.
You fucking lied.
What?
You're a liar. You're a deceiver.
I showed the
You don't have
Bisling code.
anything.
I showed the
You don't
Bisling
have-
code. I showed it on screen.
No, you're just showing some shit on the screen. You think I'm an
Yeah,
idiot?
it was formulas of the Bisling
Do you
code.
have a
Yes.
mathematical model of the location of the sun, assuming the Earth is flat? Yes or no?
How is it not modeled there?
Show me your mathematical model if you input the variables of my location, assuming the Earth is flat, you get an output. Where is that? Do you have it? If you do, I'm all ears. I don't want to waste my fucking time with you.
Yeah, I would have liked to show you if you were.
You have the mathematical model. Does someone
True.
else? Does someone
were
else want to
honest.
ask me this question? Do you have the mathematical model of the location of the sun, assuming the Earth is flat? Do you have that?
Assuming the.
And if you don't, and if you don't have that, if you don't have it, you've been wasting my time and everyone else's time. And the reality is you probably don't
So you
have
want
it.
to avoid the other
You have the
experiment now?
mathematical model.
When this model isn't.
have the mathematical
when
model.
math isn't reality.
Okay. This is not going anywhere because you lost. You don't have it.
We can
You
skip,
don't know
we
how to
can
do the
skip this
science.
point. We can skip this point. You know, you
there's no skip
excluded
this point.
on purpose. You excluded on purpose.
I didn't exclude anything. You just fucking dug your own grave.
Flat earthers.
You dug your own fucking grave. You
How
can't
is that?
produce a mathematical model after we gave you a week.
Yeah,
Because you don't have a model.
I'm a regular working guy. I'm not like doing
Oh, yeah,
doing
okay.
this every
Let's get the
day
violins
in and
out.
out.
Yeah, we gave you the opportunity to speak to as many people as possible. None of you fucking flat earthers can come up with a model. You're bullshitting people. You're fucking bullshitters.
I show here how you
You're a
threw
fucking
it out.
bullshitter.
I show
wasting my
how you
time.
throw Man
If
of
you're
Stone
such a
out.
working guy,
Get the Man of
you have a
Stone.
model.
Get people who deal with this
Stone?
every day. Yes.
Yeah,
Like
you had
Toon.
chance for a week to go talk to them.
I prepared my
Where's your
thing very well, so I
mathematical
like to.
Where's your
I like
mathematical
to-
model, Kevin?
I like to object to
Where's your mathematical
this.
model, Kevin?
I like to object.
Where's
this
your
thing
mathematical model,
completely.
Kevin? Where's your
can
mathematical
see-
model?
You can
You're
see
just
that
showing a
Bislin
bunch of
works very
bullshit.
well.
You've been doing this, just bullshit, bullshit,
You can
bullshit.
see that Bislin works kinematically
seeing
very
anything.
well. Yeah, I go
not
back
seeing
to it
anything.
because am I still sharing screen? You see,
Okay. Please stop him from sharing the screen. He's wasting everyone's time. He doesn't have a model. He's full of shit.
yeah, ask the other guys and.
You're full
I
of
don't
shit.
know how-
You don't have a model. You don't have a model. You
I
lied.
prepared 3 days.
I don't care how many times you spent. You
No,
don't know how to do science.
You don't know how to do this. That you don't see that you only do observations and no experiment. Sorry,
Where's your model?
it's only observations
your
what
model,
you're doing.
Kevin?
The purpose of the summit is
don't know
not
how
to
to
set
do
up an
science.
observation.
Admit it. You don't know
only
how
an
to fucking do
observation.
science.
We have an experiment.
You need to get out of the
and you
way
do
and
the observation
let the
of the
men do the work.
motion of a non-terrestrial object.
Okay, please mute
and
him.
you
This
write
is just talking
mathematics.
nonsense. Yeah, you're a fucking bullshit. Total bullshit. You were supposed to come here with a mathematical model. We were originally supposed to do it on live. Then we gave you guys 7 days to use whoever you wanted. You cannot produce a mathematical model because you don't know how to do math. You don't know how to do science. You do know how to talk a bunch of bullshit and put a bunch of fucking PowerPoints together. And that's what you're doing. And that's what you guys are doing. And you're taking advantage of people. That's bullshit. You lose. Is there anything else to discuss? I don't have anything else to discuss.
I think it's,
you guys fucking lost.
If I could add something quick about the attempt of a model he brought up, a flat earther named Shane Saint Pierre plagiarized a model that was by a glober, Walter Bislin, and he did show that on screen there. That model is actually the globe model. It uses a globe ephemeris of the solar system. It has the Earth 150 million kilometers away from the sun. It includes the tip of the Earth in all of the internal computations, and then it just projects it onto a flat surface to show how ridiculous it is for a flat Earth and show all the failures of flat Earth. And they've actually plagiarized that and try to use it as their own model sometimes, but it uses the distance between the Earth and sun of 150 million kilometers. So it is the globe.
Okay, so flat earthers are using a globe model to project it onto a flat surface. That's what you're saying. So bottom line, to everyone listening out there, we came into this prescribing the scientific method. On day one, they were supposed to do the math. And in order to give a handicap, we said you have 7 days. Today's goal was to produce a mathematical model. And Kevin, you can shake your fucking head all day you want. You can sit upside down, but you fucking lied. You deceived people. You did. And I don't care about what you say. What the actions are, you fucking lied. You're full of shit. And we have an actual model by the globe earthers. We have no model by the flat earthers, which shows, A, they cannot do mathematics. They don't follow through on what they say they're going to do. They just put gobbledygook shit out there because they're taking advantage of people who in a modern education system are not learning math or not learning physics. They just think by throwing out refraction, all blah, 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 vomiting shit, they're going to bullshit people. Well, you guys fucking lost. Okay, you had 7 days to consult as many. You could shake your head. You're fucking wrong. You lost. You fucking lost. You fucking lost. You and Dave can go suck each other off all day long. But you took advantage of my time, everyone's time here. So you're full of shit. There is no model, period. So you fucking lost. You didn't follow through. I have really nothing more to do. If you guys want to go to the airplane, we can, but the main thing we left was the error margin.
I'd like to, because that was some effort that we actually put into that, and
Okay.
I think that's something that it's going to demonstrate.
I just want to go on the record that the flat earthers produce no mathematical model because they don't know fucking math. They do know how to throw a bunch of slides up. What everyone saw was just noise, thinking they're going to bullshit people. So they must have gotten used to speaking to really fucking dumb people and taking advantage of them. But let me show you, this is my master's thesis. This took 2 years. This has 1,000 different equations predicting wave propagation. You can't do this shit overnight. It takes effort. And the reality is we have a whole strata of grifters who are bullshitting people. And if that is allowed to continue, you head into the dark ages. I take this very seriously because I know the amount of effort it takes to do science. And what you just witnessed today by this guy, Kevin, is absolute deception. So we did 2 experiments. You fucking lost. Flat earthers, go fuck yourself because you fucking wasted my time. It's bullshit. So now we're going to give the flat earthers. They came up with an experiment about an airplane flying over ocean towards a spot, and their claim is that the Earth is flat, therefore there will be a height difference, and we can bring this up. Let me bring it up. Prabhakar, can I share screen?
Yeah, you should be able to share the screen.
Fucking bullshit. So the claim is the Earth is flat, case one, and if an airplane's flying into this ILS tower, that at 6,355 feet, the height of the airplane, that it'll be 23 miles, this hypotenuse will be 23 miles from this location with a 3-degree span. If the Earth is a globe, it'll be 21.7 miles. Am I right? That was a claim. And for this, you were supposed to derive the mathematical model to predict that. And as a part of that, what came up in the last discussion, so you can't say you didn't know, was a very clear question: what is the error margin of the measuring devices? Because if the error margin is such that it is within that range of the differential, your experiment is bullshit. It's useless. Am I right? Isn't that what we discussed? Yes? No?
Yeah.
Okay. So today we'll again start with the globe earthers, present your mathematical model with the error margin, then we'll go to the flat earthers again.
I
had
thought
a very little talk.
I thought they started first. It was their experiment. I'm fine either way.
All right. They can go first. Go ahead. But what we're expecting to the audience and everyone, that we agreed upon, that you would present the assumptions and a mathematical model, not slides about random shit, the actual methodical process of building your mathematical model, right? And if you don't do that, I'm going to fucking cut you off and we're going to end it. Let's go. So your second shot, Kevin. You already lost once.
So full screen. Just letting you know that when you drift, that is when someone else, when someone is talking something he doesn't believe. But okay, let's start with the error margin. Full screen. So we are clarifying some of the lies and mistakes from last meeting's margin of error claims. To genuinely ask for error margin is, of course, a legitimate request, which it wasn't. But here I present FAA documents. We go even through the history. Here we see that 13 years ago, although the microwave landing system were not yet used in the US, they were looking at potential accuracy level of plus or minus 84 meters. Over the past 13 years, it's quite likely that the vast majority of airports have upgraded their hardware and to match or even surpass this figure of plus or minus 84 meters of DME accuracy. Regardless of whether those upgrades took place in some time in the past 13 years, we are indeed using the ILS in this experiment within the area of its native range of 22 nautical miles. Other instrument landing systems than the one mentioned here involve far larger coverage areas. As you can see here, 13 years ago, they also thought about 92.6 meters, but 1 year later, this is here. 1 year later, they published the paper quoted last Saturday by Dan. On page 1, the author cites that DME accuracy is better than FAA requirements. On page 2, Dan highlighted the figure of 0.6 nautical miles. The author does not specify whether that is a total of 0.6 or it is plus or minus 0.6 nautical miles. Given the statement in page 1, along with the rest of what I'm about to cite, we can easily conclude that this is a typographical error. The real question is why we didn't look here at the table down. It says 0.085 nautical miles at 89 equipment. So, so the real question is why Dan made the decision to cherry pick this typo, or what is written here as 0.6 as a bullshit tactic, or whether Dan simply doesn't look through papers enough. So we go through flight test data, which was obtained from both the FAA and Boeing in determination that current DME accuracy is actually better than FAA requirements. It says this in multiple places within this document, that current DME accuracy significantly exceeds the current standards, and this was 12 years ago. To be clear about this text, 0.05 nautical miles equals 92.6 meters. That is already twice the resolution of the primary flight display's ILS tower distance indicator, which shows 1/10 of a nautical mile. So the accuracy level has come a long way in the past 12 years. Now we come to the present. This year, the FAA accuracy requirement for DME hardware, which is used with ILS, must be 75 meters or less. So the DME error is significant. So the DME error is insignificant. Now we get to the error margin of the ILS angle measurement, the second part we were talking about last Saturday. The FAA angle tolerance for an ILS signal pair is less than 4% of the nominal angle, which is almost always 3 degrees. Those 0.12 degrees amount to 1/3 of the travel distance from one dot to its center on the ILS display between 2.65 and 3 degrees. As a result, expected measurements for each scenario do not overlap. There's still a significant spread between the two in all aspects of this analysis, and I will show that. This diagram may not be to scale, however, it is proportionally correct. The lightest gray shading represents the beam divergence, which Dan requested to know about, 1.4 degrees here. This light gray shaded area has nothing to do with the gray shaded triangle seen on runway approach diagrams, just like the one MCToon shared on his screen at 1 hour into last Saturday stream. The runway diagram triangle around the 3-degree line has to do with whether there are obstacles in the way, which the pilot needs to know about during his descent, as you can read here. If there are obstacles present, the bottom half of the triangle is even not drawn in the diagram. So that has nothing to do with the margin of error, as Toon presented it. But this light gray triangle here represents the full deflection or beam divergence to the ILS slope gauge on the primary flight display from 2 dots below center to 2 dots above, with a total spread of 1.4 degrees. Yeah, it's what your display is able to detect. As you've seen in all previously presented diagrams, as well as the animation, the angular distance from 1 dot above center on the gauge to its center is 2.65 degrees to 3 degrees. Now we come to this thin tan shaded area on both sides of the 3-degree slope line. This represents the 0.12 degree ILS angle. The current DME margin of error requirement is in the small box on the left here. This is the current DME margin of error. So we now will add both error margins. 1/20th of a nautical mile, and that is twice the resolution of the ILS distance readout on the primary flight display. So taking the worst estimate scenario for both margins of error, the overlap comes to a total of 0.58 nautical miles. However, in obtaining a larger data set, the data itself will serve to critically attenuate both uncertainties through the simple process of averaging the resultant figures. The larger the data set, the smaller the uncertainty. So I hope this permanently puts to rest any issues of margin of error serving to invalidate this. There's a huge amount still 0.6 nautical miles almost in the worst case scenario. You have both the values as you wished for. Yes. That's it for the objections for the margins of error. And so it is a valid experiment, and we gather more data, and you could find a lot of airports, because this was a question also over water. I show a couple here, some examples which were 20 nautical miles above water, more or less. And we can also show that previous data, if you don't want to spend any costs, we showed the prediction from 35 nautical miles. For flat Earth, we were 1% off, and for the globe, we were 1,000 feet off, almost here 10%. So this was one thing I said. We didn't do the exact experiment where we remained at that altitude, but we asked pilots to show their primary flight displays. And as you see here, we have a significantly closer outcome for flat as for the globe. And yes, we will continue to gather more data. The question was whether the costs of the flights. We looked up some planes. It was, am I sharing full screen that I can just switch the document, or do I have to switch, turn it off again? Where's my document?
You have to usually switch the document. That's what I had to do, Kevin.
I can just switch the document, okay.
Just click share again. It should bring up a
I need to click share again, yeah? Okay.
Yeah.
No, do you see the plane now here?
No, we see previous data.
Okay.
It's just
okay. Wait, yeah. So I screen share again. Screen share. Let's screen share the planes. So examples to rent would have been here $125 an hour, and you even can fly with IFR. You don't need this. The VFR could be even cheaper, but $160 an hour, we said, like 2 hours would be enough. Another one, $226, and it is all wet, so it means it's still already with fuel. So it's not so expensive. You can have one try for $400, and this will give you 10 results, or 20, yeah, maybe 15, yeah.
Can I ask a quick question for you, Kev, real quick? Kevin?
Yes.
Yeah, can I ask you a quick question? So the cost of these planes, does that include a pilot, or is that just the plane itself?
That's the plane itself.
Okay, thank you. I just wanted clarification. Thank you.
Mm-hmm. So did you see the trial that we did? So even
so where's your mathematical model?
I can bring it up again.
You're supposed to include the error margin.
Yes.
And we do the mathematical model per the agreement that was made last week.
0.6 nautical miles are the difference, but I show you the whole formula again. This was from last presentations, from last Saturday. You can just bring up the last week's presentation. So it was but I showed the difference between globe and flat prediction.
You're not doing the globe prediction. That we got that covered.
I showed even with the result here the globe prediction.
No, you don't. You don't.
What we did?
You don't produce the globe prediction. I produce the globe prediction.
Wait. did you not understand the instructions for each experiment?
Idiot.
The flat earthers produce their model, the round earthers produce their model. So each person, which you agreed, so flat earthers, so globe earthers for the sun model produce their model. You didn't produce anything, thus you lost. Second is
you can ask other ones. Yes, I'm not every flat earther. You assume I act like everyone else, yeah?
Yeah, you are, because you're in communication with them. We know that. Okay.
They are done
fact,
with
your
doing.
entire
They know that you're shit showing there.
They're
and
scared
now
of
you
me.
have nothing to say.
They're scared of
In
me.
fact, the airplane model, Kevin, was stolen from a guy called Stone, who was banned from this. Okay.
And why? Why is that? Why is that? Why is that?
And now
Why is Stone banned, please?
I don't have to explain that.
But because you have
Yeah.
nothing.
No, you have nothing. You can't.
No,
you
you
can't
have
even
not.
do
You
it.
just exclude every
issue is,
mathematical
where is your
good
model?
flat earther,
Where
and
is
you
your
want
model?
to.
Show us
you
your
want to
model.
go with me?
Let's stay with the program, and you can do this with other idiots, but you're not going to be able to do this with me. Where's your fucking model for this? For the flat Earth model? If the Earth is flat, where's your mathematical model? And the globe Earthers present theirs. Do you have it or not? We can go back to the video. You agreed that you would do the flat Earth model with the error margin.
You want to show the video of the error margin, or you want to tell
No,
me why your test is not
You're supposed to have an
good enough?
equation. This is for your airplane experiment. Where's your flat Earth mathematical model predicting the height of the airplane, or that hypotenuse, as a function of all the other variables? You're assuming it's flat, plus adding the error margin. That's what we agreed to. Do you understand what you're supposed to do? Or do you want me to like...
page 7. Wait. Okay, I need to...
Yeah, last time we
stop
left,
screen sharing.
you showed us an equation.
We don't see your PowerPoint.
Okay, yeah, wait, I will screen share this page 7.
You're supposed to produce a mathematical model. You didn't do it for the sun, and we want to see it for your experiment. You had 2 shots. You've already lost on one.
Press. So...
Yeah, so show us the equation. Not like random
Yeah,
pictures.
my mouse is hanging.
Yeah.
I don't want...
We want to see the equation.
The mouse is completely lacking now. That's why when you include someone who does this every day, it's easier than trying to make fun of me. But you have to exclude everyone else. My screen is frozen.
Okay, so can you mail your thing to Dr. Prabhakar, then he'll display it?
Yeah. ILS experiment images.
Prabhakar, give me your email address, or I'll give you my email address. Mail it to you. Have my email address. Send it to me, and then I'll display it for you.
Okay. Mail to Shiva Ayadure. Show.
So this is the PowerPoint that you want me to display?
I sent you something now.
Hold on 1 second. Is it a PowerPoint?
It's a PDF. Wait, no, it's... Yeah, it should be the one I sent you, yeah?
You sent it to Integrative Systems, okay. Integrativesystems.org? Okay, I'm waiting for it. It says ILS experiment images.
Image 2, top half.
But this is a PDF with 2 images. I don't see any equations in this.
It has the sine function. sign 3 degrees.
Prabhakar, I'm sending it to display, okay? Prabhakar? Hello?
Yeah.
Prabhakar, you there?
Yeah, I'm waiting for it.
I just sent it to you to display. So again, if you could mute everyone for a second, Prabhakar. The agreements that were made and the promises that were made were that we would come to this meeting for the 2 experiments to follow the scientific method.
Oh, shit. Dr. Shiva, can you unmute yourself? I accidentally muted you.
Okay. So just before, if you could unmute everyone except me, what was agreed to in 2 pre-meetings and in the last day 1 meeting, and we took handicap for people who didn't know math, so they could go consult with anyone that wanted, that they would come to this meeting for the experiment on the sun's location, that the flat earthers would have their mathematical model predicting the sun's locations, which they have failed to do for the record, and the globe earthers would, which they have succeeded in doing. Then for the airplane experiment, the flat earthers would come with a mathematical model, including error margin, and so would do the globe earthers. And so what we're waiting is for the flat earthers to show us their mathematical model, including the error margin. And that's what we're supposedly going to see right now. Let's see if we see a mathematical equation with the error margin. Go ahead, Prabhakar.
All right, can you see my screen, Kevin?
We can see your screen, but Kevin is not here now.
We lost Kevin. Oh, Kevin.
Don't blame
Because Kevin
Kevin.
is having screen sharing issues.
Don't blame Kevin for running. Smartest thing he did
All
yet
right,
today.
So he has
dipping out.
a model of.
Well, right, but that doesn't include the error margin in there, does it?
No.
Um,
No error margin. I'm muted
No,
on
I
their
think
side
this
right
is-
now.
what we shared last time before we asked him to incorporate the error margin. I think it's probably not our slide.
All right. What happened? Did he leave?
I wonder if he tried to drop and connect again to see if he can reshare.
Yeah, just give me a minute if he gets back up. Just may have to reboot his laptop or whatever.
All right, we'll wait for him.
And I believe he had a separate document that had margin of error. If I remember correctly, he was trying to find the correct window.
Let me see if he sent that.
He did mention the margin of error of DME and the angle, and he missed.
Dr. Kevin's back in the waiting room. Can you let him in?
Yeah.
Kevin, we have your diagram up.
I don't see him in the waiting room.
I just saw him in the waiting room.
He's already in. I just see him.
We have to unmute him.
All right.
So Kevin, your equation for, well, what we're actually predicting is the nautical miles, aren't we?
Yes, the altitude is fixed. I don't, because in your agenda, you wrote something about you want to address if the altitude is changing, but the altitude isn't changing. We want to keep the plane steady.
No. So
And-
Kevin, simple question. What is your input and what's your output in your model? Yes.
I have it written down somewhere. It's the input is the angle, was it? And the output is what you need to get is the
what you need to get, what you're looking for is the output is the distance, and the input is the fixed altitude and the angle. The angle is fixed and the altitude is fixed. Yes. Because every ILS has a fixed angle, but some have 2.9, some have 3,
So
some have
where's your,
3.1. Yes.
can you show us your full equation then? Where's your hypothetical? Where's your
Yes, but you see this without error margins, but this I will send you the one with error, or maybe I can screen share here. Wait. But you see here this equation on the top with the sign, and the bottom one for the globe, the equation. And let's see.
No, but wait 1 second. Kevin, stop. Where's your equation including all the variables?
Yeah, I had it on the page 7 of the last.
Can you send that so we can display? The equation should be you're saying the output is what, the height or the hypotenuse?
No, the output is the distance.
Okay.
The distance to the tower. The level approach to, yeah.
Right, so you need to have some equation that distance d, let's call it, is equal to some function of all these variables, right?
I showed the error margin, but I will try to.
Can you show us the equation? Because that's what we're gonna. Yeah.
Margin of error. Send it to Shiva. Telegram. This margin of error. Final. Yeah, there it is. Send it to.
Right, to everyone listening, we're looking for an equation. Kevin is saying the hypotenuse is the variable he's predicting, the output. That needs to be a function of various variables, right?
Yes.
Okay, so did you send it?
Yes. Why didn't it send any document? Wait.
You got to attach it. You have to attach it.
Sorry. ILS presentation. Dann gehe ich dahin, sende das hier vom Gerät. Margin of error images final. So now Shiva, F something, and send it. So now it is. Now it's out. Margin of error. Image is final. And then it is the last. Check for the last image in there.
So you're claiming you have your. Okay, Prabhakar, I'm sending this to you.
All right.
So you can display it. It's called HH as a subject line. Okay. Just to let everyone in the audience, so people don't get confused or manipulated or deceived in any way, this is what we're talking about. This is, if everyone sees this variable D, can you guys all see this? Dan? Brian?
Yeah.
Okay.
Yes.
The goal is the formulae is trying to predict D under the flat Earth condition. So it's going to be D is equal to some function of a bunch of variables, plus or minus some error. Similarly, the globers are going to have their model down here, okay? Which is going to be d is equal to some function, a different function, g, based on their variables, okay, whatever their assumption is. So this was what the purpose of today was, and we extended the meeting. So I'm frankly annoyed that we didn't do this for the first one, and we were bamboozled, and I hope we're not going to get bamboozled on this one. So what we're looking for from Kevin is the actual formula.
Yes, you had the error, the formulas without the error margin. But now, look, I can even screen share now. So I have it here.
Is Stone helping you? Okay. Screen share?
I have to screen share, help myself.
Okay. Help you.
Again?
Okay, but I hope everyone sees this is what we're looking for. This is the formulas that we're looking for today.
Yeah, but maybe you haven't even seen the image with the full error margin document. I presented it before, but it should be in the email I sent you because I can't get it.
I just sent it to Prabhakar to bring up. Can you bring it up?
Yeah, and it's the last page in there, the last page.
Yeah. Wasting a lot of time. Where's the,
there it is. You have all the...
No, but where is the formula?
There, it says sine 3.12, the angle equals the altitude
but
over h.
You have all these other variables, right? Like the ILS, the beam distance, the beam, all that kind of stuff. Did you not include that in your model? This is just...
It's one page before. It says here, see here. So when you look at this... Okay.
Kevin, you don't need to teach me math. This is like third grade math. But this is not really a robust model. But if that's what you want to do, you're just saying it's what?
6.6 nautical miles difference in between.
But where's your
no overlapping.
Model? Where's your model?
No overlapping.
That's your model?
One underlined figure subtracted from the other equals the plus or minus value of 0.58.
I think
0.58.
Let me help you.
19.
Your model should be H is equal. Your model should
invite him then.
Okay.
19.8. Yeah.
Okay. Typically of an output, which is your H, is equal to some function of an input. Okay. So I think you're trying to say H is equal to 6360 over sine 3.12. Is that what you're saying?
The sine function, yes.
Right. So let me help you. So you're saying this is your model. And correct me if I'm wrong. You're saying D is equal to, which is that distance, is equal to, what is it, 6360 divided by sine of 3.12 degrees. Is that your model? I think that's your model, right?
Yes, it's showed on the last page.
Okay, can you show it on the last page?
But you can't. You have to scroll down to see the plus or minus error margins on the scale. On the bottom, you need to scroll down a little bit more. See, you see there the...
Yeah, I just don't think you understand what a mathematical equation is, because you're supposed to present it as a mathematical model. So you need to go learn that, okay? Let's go to the...
You have two models there, yeah.
Well...
And you have two different outcomes, and you have the prediction, and I showed you one result, which is 1% to the flat and 10% off the globe. And we would like to do more tests. Yeah, support Stone on doing more of those, and because the sun isn't doing anything, so
all right.
It's not.
You presented your model? Can the globe earthers go now present their model, assuming using your own experiment? Okay, let's go to the globe earther. Present your mathematical model now. I don't even know what you're presenting there, frankly. I didn't see an equation clearly, but go ahead.
All right,
It said sinus. Oh man, I thought you know math.
I'm sharing my screen.
So who's presenting this?
I am.
All right, go ahead.
All right. Do you see my my screen now?
Yep, go ahead.
Okay. So we need to compute the distance from the ILS transmitter that the airplane will intersect the beam, as defined last week. The difference between globe and flat is going to be what's at being tested here. For a globe, the angle will be slightly different because the vertical vector is different in a different position, say 20 nautical miles away. It should be about 1/3 of a degree variance in the vertical vector. So there's several variables to consider. We've got the elevation of the plane. These are inputs. The elevation margin of error. We've got the coefficient of refraction because there is a pressure gradient. In fact, if there wasn't a pressure gradient, the altimeter wouldn't work at all. We've got the glide slope angle and the glide slope margin of error. We've got the intercept position. You've got the leading edge of the beam, the center of the beam, or the exit of the beam are different places that you potentially could use to measure your distance. Then you've got the margin of error of the distance to the transmitter, as Kevin was saying, the DME margin of error, and the transmitter height. And there's potentially some other variables that are less significant. All of my citations you can find on mctoon.net/globe-ILS. So everything that I list as a citation here is already uploaded there. You can go download it and see it for yourself. So the elevation of the plane right here, the example that we're going to look at is 6,355 feet, but at that elevation, a pressure-based altimeter is not precise to 1 foot. It is precise to 270 feet, which is plus or minus 135 feet. So that margin of error is going to be one of our inputs. And down there at the bottom is the citation. The coefficient of refraction for RF in the air commonly is a K value of 4/3. And we can use if we're not able to measure it, we'll have to use a range. I will use in my example, I'll use half of that. I'll use 0.167, but it can be it will have to be varied based on the actual conditions. So another margin of error on that, which I don't put the margin of error up for that one. I'm just using a solid 1.67 in the my example that I'm going through here. The glide slope angle, different airports have a different angle, as Kevin did say. I'm using this one here. Nashua, New Hampshire has one that is 3.0. And it is a category 1 ILS at this particular airport. And different ILSs have different, or different categories have different requirements for precision. And it should be noted that ILS is only certified for 10 nautical miles. We're using this at 20 nautical miles, which is outside the certification. So it makes it difficult to get certainty on the margins of error, because they only certify it for half of the distance that we're trying to utilize it for. Anyway, so at 10 nautical miles, we're going to have to use that because that's all we get. The structure tolerance for category 1 is plus or minus 30 microamps. Now this is a transmitter, as Liz was talking about. In the outer zone, this converts to approximately plus or minus 0.14 degrees. Now, Kevin actually said 7.5 degrees for a category 1. Or 7.5%. Okay, so I'd need to convert that to degrees. Anyway, the source air ILS glide slope standards. And then the distance measurement. Now he said that the 0.6 was a typo. I don't know if that was a typo or not, but fortunately, I can modify that in the calculator to get a different error bar for the DME. So the DME is a distance measurement device as part of the display on the airplane. And right here, Kevin wondered last week, he got confused because I said that the height of the beam is 0.7 degrees, and he thought that meant margin of error of the beam. No, that's the height. The beam coming out from the ILS, where the airplane is going to be saying, yes, you're in the beam, is approximately 0.7 degrees in height. And the source there, the FAA Aeronautical Information Manual, Official Guide to Basic Flight Information and ATC Procedure. That's this. Now, this is approximate. So if we're going to be doing anything, we would need to get better measurements and certification on the edges of the beam if we're going to be using the entry and exit of the beam. So any of the points can be used, the entry point, the center point, or the exit point. They all present their own challenges in precision that will potentially greatly increase the margin of error. So right here you can see on the primary flight display, on the right side of it is a triangle, and the vertical position of that triangle shows where you are within the beam. So when it's at one edge or the other edge, you're just entering or exiting that beam, and then when it's in the center there, that's when you're in the middle of the beam. Approximately. There's no guarantee in any of the stuff I could find saying that this is any sort of guarantee of being in the center of the beam. Additionally, how long is that within the center of the beam? Unknown. How long does that triangle sit there right in the middle before it moves up or down? We don't know. So I estimated that it might be there for 15 seconds as we're flying straight. We can adjust this, but if it is there for 15 seconds while you're traveling at 120 knots, that's 1/2 of a nautical mile. So I added that into the margin of error. The transmitter height is not super easy to find, and it doesn't add a lot, but I am estimating a 10-foot transmitter height for Nashua in my example that I'm going through here. So here's the overview of the input variables to the computation. And again, the citations are all on the mctoon.net/globe-ILS. So I used GeoGebra, which is a visual geometry calculator, to put all this in. And this is what it outputs here. And you can see there the margin of error of the flight, of the altitude. That's the horizontal curving line there. It's level, not horizontal, actually. And then the up and down on that. And this scale is about 10-to-1 vertical to horizontal scale because the globe is so large in comparison to the elevation. So I had to stretch that scale. And then you see that beam width there. That beam width is the margin of error of the beam width. So here's the beam entry for the globe in this particular example. The minimum distance at the beam entry is 19.45 nautical miles. The straight line distance, that's the center of the beam, is 21.39. And the max distance when you exit, actually the max is when you enter the beam, is 23.46. This one here, the center, this is the one that's more analogous to the one that Kevin is looking at. And so using the same numbers here, we get of the center of the beam with the margin of error, we get between 20.92 nautical miles and 17.4 nautical miles. So we have nearly 4 nautical mile variation in when we will hit the center of the beam on the globe model. And then the beam exit here, similarly, it's a little shorter distances. And I'll zoom in here on the actual margin of error positions. We've got the curving level to the surface of the Earth one with the dash in the middle, and then we've got the top and bottom bounds of the margin of error. We've got the beam width. This is just the center of the beam with the margin of error that's at 10 nautical miles, not 20. Who knows what it is at 20? It's unknowable probably. But and then I put a point on the far upper right there. That's the one extreme of the margin of error, and on the far left is the other extreme of the margin of error. And I can show you in real time. Here is the actual GeoGebra, and you can see here we can vary all these inputs. So we've got the glide slope margin of error, the altitude margin of error, the transmitter height, Then we've got the DME, the distance margin of error, and the refraction here. I'm using 0.167 for refraction. So there's how it's all calculated. Again, this is linked on my webpage as well, so anybody can use this. So it gives us everything we want there, and it includes all of the math necessary to reproduce this yourself here. So any questions about this?
So, Mike, I got a question. So what you're saying is there's nearly a 4-mile margin of error, plus minus, right?
Yes.
Roughly 4. So according to the experiment proposed by the flat earthers, is that the difference would be what? Let me bring this up in the PowerPoint. Would be the difference between 23 miles versus 21.75 miles, which is basically a 1.25 mile difference, right?
Yeah, it's ours it's about 4 nautical mile difference.
No, I know,
Yeah.
but the difference, if the Earth is flat, according to them.
Oh, between the two, yeah.
Yeah, the distance between the tower and the airplane would be 23 miles. And if the distance for globe will be 21.75 miles, right?
Well, the distance for globe is this is what's interesting. The prediction for flat Earth is 100% within the globe prediction when we include the margins of error. And Kevin didn't include. He only included margins of error for things that we brought up last week. Apparently, we have to tell him margins of error that he needs to consider. But
no, I understand that. I understand that. But I'm saying, in his experiment proposed, I can share my screen. So just putting this all together to show the fact that the experiment that the airplane is basically useless because of the fact of the margin of error being at minimum 4, right? Plus or minus.
Yeah.
So if we bring this up, this is to everyone listening. This was the experiment proposed by the flat earthers, which the globe earthers were willing to do. And the distance here is what we're looking at. According to the theoretical framework of the flat earthers, that if this airplane flies at 6,355 feet above this, as it's coming into this ILS tower, the flat Earth distance from the tower to here measured with this beam, which has all these different errors of margin, but they're saying definitively be 23 miles. And for the globe Earth, if it in fact was a globe, would be 21.75 miles. That's how they teed up, right?
Yeah.
Kevin, Mike, okay. The reality is at last meeting, we said, how can it be exactly 23, exactly? Because there's all these variables. The tower, right? I'm sorry, the beam, right? The DM, a number of things, which should have been included in the model. But the globe earthers essentially gave the flat earthers feedback saying, you're not including margin of error. So the point is it can never be exactly 23 or never be exactly 21.75. The globe earth model is predicting to be 23 all the way up to 27, right? I'm sorry, 25 or 23 down to 21. Am I right? Mike? This is 23 miles plus or minus a margin of error, which you've calculated.
Yeah, I'm sorry.
Right?
Yeah.
Right. And you use a globe. Just let's use your model. Your number could be 21.75 if you want to use this number, but a 4-mile error of margin.
Yeah.
Yeah, Toon didn't even get that. We showed a localizer beam, and it's a glide slope has 2 beams, and the signal strength of both are the important part. So here's a completely wrong margin of error. Also, the refraction is not significant, but showing everything with 1 beam is completely wrong. We have 2 beams, and you compare the strength of those 2 beams. I showed it. You have 1 beam angled horizontal. You have 1 beam angled at 6 degrees. And that's why you have the 3 degrees in between. And you compare the 0 and the 6 degrees angle. And Toon didn't do this. He showed the localizer beam, which is a complete different story. I showed the FA.
So this is why I've been asking you for your formula, Kevin. If you go,
Yeah, I showed
Mike-
you, and you didn't get it.
no, I did get it. I showed it. That's not a formula. That's just a.
0.6
That's a-
nautical miles
that's-
difference.
that's not a
It's
formula.
not 4 miles, but what was
let
it?
me-
0.6.
Let me take you to third grade. Mike, can you bring up your? Can you bring up
How
your?
can you when there's no formula?
Let me bring up your assumptions. Mike actually has a formula. Mike, can you bring up your assumptions, please? No. So you see right there. No, that's your inputs. I'm talking about your assumptions, the various variables, your input variables. Go back, Mike. It was
Beam
before.
entry, which
The
beam?
variables-
Is it 2 beams? It's
Right
1
there.
beam.
Okay, see this? So
Scroll
the-
back and see 1 beam.
wait,
He says
wait,
all the time.
don't interrupt me. This is
But
the elements to his model: elevation of the plane, elevation of the margin of error, coefficient of refraction. In your model, all you have is the elevation of the plane, right? And you calculate that by 6355 divided by the sine of the angle. And maybe you have the angle, which you fixed at exactly 3.1. You don't even have variables. You just have.
I showed the transmitter. I showed all of this. What is what is relevant? I showed the transmitter height. I showed the glide slope angle. We had these two. If you didn't listen to me at the presentation, I showed the glide slope angle error margin, and I showed.
Yeah. So can you
Also
show me the formula that calculates D based on all that? He's got the formula and he's got it put up on a website where anyone can play with it. Can you show me your formula?
We uploaded it on the website. I showed you in the document, the last page, and you said there is no formula. So it was in front of your
Kevin, I don't think you understand math. That's not a formula.
sine function is no formula.
No, it's not a formula including the glide slope angle. Where's the glide slope angle in there? You just gave a fixed number, 3.1. There's no margin of error. What's that?
The margin of error is there also included, but you want to bullshit now, but I don't know.
I don't think you know what an equation is.
Okay, no, but you saw the difference there. It was 0.58 degrees.
No, I don't think you understand what I'm saying. It's like you're a child. I'm talking to a fucking child. Do you not understand what a formula is?
Yeah, you did. You say sine function is no formula. This is.
No, you didn't.
Who doesn't understand?
No, you have all these variables. Okay, in that formula, let's bring it up. Prabhakar, bring it up. Where's the glide slope angle in there? And the margin of error? Prabhakar, can you bring up his formula? So in your formula, where is the glide slope angle in here?
This is the max. The 3 degrees is the media, the beam normally, and you have one equation with the 0.12 more on the top, and you have on the bottom you have the sine function with the error margin 0.12 degrees subtracted from the 3 degrees. So you have this difference.
All right, let me have the globe earthers ask him the questions so people recognize it.
So you don't understand this, or you want to?
No, I understand it, but you're not understanding what a formula is. An actual equation relating all the inputs to your output.
You have a maximum and the minimum of the margin of error, and you compare them, those two, and you have 4 formulas here.
So you're saying your maximum margin of error is 0.12 above and below. Is that what you're saying?
For the angle.
For the angle. That's what you're saying. That's it. And so you're just giving these values based on that. Is that what you're saying?
Based on what the Federal Aviation Association is providing,
Okay.
yes.
So now compare your model. Let's go to the globe earth model.
I think he ran the same formula multiple times, one for different boundaries on the margin of errors. I think
so
what he
got
did.
4. Right. But what I'm saying is go to your variables, Kevin, or your variables that you used in the model.
My variables, what I have, I look for the angle error of margin, or you talk about not error margin, but you talk about my variables. This is still
bring up your variables in the varying inputs that you used in your equation. That one slide, Kevin.
I used the angle. I used the distance. I used the height. You know the triangle now, no? And you.
Yeah, the guy Alex who called the hypotenuse degrees, right? That guy.
Alan.
Alan, who thinks hypotenuse is measured in degrees. The math genius. That guy. Yeah. No. Prabhakar. It's Kevin. Can you? Not Kevin. Mike, can you share your variables?
Yeah. Give me a second.
Yeah.
There we go.
I have something to bring about the glide slope too after Mike's done.
Yep.
All right.
Yeah. So this is to the flat earthers. No, the variables, Mike, not the in the formula, Mike. The other slide, yeah.
Well, you mean this?
Yes, that one.
There you go. Okay. Yeah.
Yes, but also you had a slide. Go to that slide where you had glide slope. It listed everything.
Oh, all the variables from the beginning, Mike.
Yeah.
Yes, from the beginning, Mike.
There you go.
Okay. So to anyone listening, these are the various things, Mike, you're able to change in your formula, right?
Yeah.
Elevation margin of error, coefficient of refraction, glide slope angle, intercept position, transmitter height, and there's other variables, okay? These are the variables. When I said F of variables or G of variables, that calculates the distance, right, from the airplane to the ILS. So to just educate people, looks like flat earthers don't want to be educated. These are the variables that are used to calculate that. So either flat earthers are using these variables, they're not using them, they're using other variables. So my question to you, Kevin, is, you're using the elevation of the plane? Yes or no? You are, right? But you fixed it.
Yes, it fixed. Yes.
Yeah, you set it to 6355. The elevation margin of error, do you have a value for that? I don't think you do, right?
No.
Okay. Coefficient of refraction.
Because the FAA pressure is accurate.
No, I think what we're saying is this experiment assumes whoever's flying that airplane, that their altimeter, when they say they're at 6355, there's no margin of error, which is not true. I don't think any altimeter, when it says I'm at 10 feet above the ground, it's exactly at 10 feet. Do you follow? So they've included an elevation margin of error. You have not in your model. Okay? The coefficient of refraction, they have included in their model. You're saying it's not necessary. Is that right, Kevin?
The height is so much fixed that what do you want? And we have so much of a change, slope to flat, that this.
No, what we're saying is the altimeter itself is a measuring device. All measuring devices have a margin of error. Agreed?
Yes.
So how much is?
Yes, I agree. Kevin, do you agree?
Yes.
Do you agree, Kevin?
I agree that it's negligible.
Well,
No, you don't agree.
that means you don't agree because you have to include it. Every device anyone has used, if you use a ruler which only has a quarter markings or an eighth markings, the margin of error is plus or minus 1/8 because you can't read beyond that. Do you understand? So the issue that an altimeter itself has a margin of error. And what Kevin is saying is a margin of error for the altimeter is 270 feet plus or minus 135 feet. That comes from a document. So that means you believe that 135 feet is negligible when you're trying to measure a 319 feet difference. Do you understand? To everyone listening, flat earthers are saying that if you use their experiment and if it is a flat earth, the flat earth will be 319 feet less than the round earth. Am I right? That's what you're saying. But if the altimeter is 135 feet margin of error, then 2x of that or 3x of that, you're off. okay? And that's the point here. You did not include the margin of error of the altimeter. They have included that. You've conveniently left that out. So if you want to go redo your model, you should include that. But that's pretty significant.
You have the same height for globe versus flat.
What are you trying to?
He doesn't.
No,
Kevin, you don't understand margin of error.
I don't think you understand what margin of error is.
No,
You
he
need to
doesn't.
go back.
I understand, but we fly at the same.
Grade. And this is the problem with all you guys. You guys are just talking shit and you don't know basics. Do you know what margin of error is?
I showed two examples.
No,
I also showed the 75
explain
meters.
to the world. I'm giving you the stage. Explain the term margin of error.
It's what could lead to results which are not correct because some instrument is not reading exact or some variables are changing. Yeah.
Okay, Dan, do you want to explain margin of error? Do you want to explain margin of error in something that
This makes the Earth a globe. Does this make the Earth a globe? If he explains it better.
No, okay, no, because you don't know how to explain it. You know,
I know what it is.
You appreciate.
Yeah, you have to. You have to fuck with someone who's not.
I don't think
English first language because you can't.
I don't think you have any appreciation for science and the effort it takes.
Mm-hmm. Yeah.
Terms have to be precise. No, terms have to be precise, not something fucking you want to say. Dan, you want to explain what margin of error is?
Yeah, so when we did the sun experiment, what it is my math equations had a half a degree of error margin, and that's just based on the simplified ones that we did versus the complicated computations. But I also added in the error margin of the GPS, error margin of the inclinometer in the phone, also the error margin of the software that we're going to be used to measuring this, and as well as other error margins like refraction at sunrise and sunset. So these are the different variables we have to account for. We add them all up, and cumulatively, we were confident in saying that our error margin was 1% when the sun is above 10 degrees over the horizon, or 2% if it was below 10 degrees over the horizon.
Yeah, to everyone.
But do you know that what is averaging? Can I pick something?
Can you mute everyone, please? I just want to explain this to the crowd because I don't want people to make other people dumb because the educational system made them dumb. When you're doing very complex experiments, particularly in physics or biology, or sometimes you're going out to, 10,000 or 100,000 digits, 0.000001 or 0.00001. When people are going out to that, or even anything less than that, you're using instruments. Instruments have margins of error, and margins of error can be multiplicative. And when you're doing this, in all experiments, the number one thing is margin of error. It was MCToon who had to even tell the flat earthers to put a fucking margin of error. This tells you the ignorance of this fucking community. Moreover, the margin of error of the altimeter is not included, which is the height. Their entire basis is the airplane is going to fly at exactly 6,355 feet. That is based on an altimeter. Well, you're never going to get that. You have a number right here that the ICAO document says for a pressure altimeter is 270 feet plus or minus 135 feet, which means a margin of error can be, what is that, Mike? If you can calculate that, could be 400 and what?
No, it's 270. It's the margin of error.
It's 270.
Yeah,
sorry, 270
plus or minus 135.
Plus or minus 135. So in this experiment, the globe earthers are saying that the height could be as 319 feet, right? Between the globe and the flat earth.
200.
Well,
no, it's the same elevation above the surface of the ground for either flat or globe. Just that it's not exactly 6,355. It's that number plus or minus 135.
Right, plus or minus 135. So the point is that the margin of error is not included in the flat earth model, just in this one measurement. So there's various areas where margin of error can come in. The altimeter, go back to your previous slide, Mike, which is not included. The second is the coefficient of refraction is nowhere in the flat earth model. The flat earthers claim that refraction is not an issue. Well, apparently they don't understand pressure gradients, okay? That refraction is an issue. The other thing is the glide slope angle margin of error. It was included after the Globe Earth team brought it up. And I think they have included 0.12. Is the Globe Earthers have any problem with that?
Well, in their model, I guess they can. They're responsible for their own model, and they gave a percentage of 4% for a Category 3 airport, and 7.5% for a Category 1 and 2 airport, which seems reasonable.
Okay, so that's reasonable. Then the intercept position and the distance to the transmitter margin of error is not included in their model. Is that right?
They did get the distance, the DME. They had a different value than we did, but we can do deeper research on that. But they did not. They assumed that when looking at the intercept of the center of the beam, they were 100% accurate. There's an unknown margin of error there, and so I just estimated that it would take 15 seconds from when the diamond indicator was, got to the center of the indicator
I think stop
and
right
left.
there, Mike.
Yeah.
Mike, 1 second. The reason you're saying it's unknown is that distance is a function. All of the FAA's only providing margin of error when it's 10 nautical miles from the ILS, right?
No, it's even worse than that. It's not designed to give you an exact position. It's just when that little diamond slides up and down, you have a relative idea of where you are within the beam. That's all you get is a relative idea. What's the margin of error of the relative idea? Unknown.
I see. Okay, so we don't even know. So what the Globe Earthers are saying, when you're flying in, if you wanted to do this experiment, you're looking at this little triangle, right, or that little line. If it's in the middle of both those two triangles, you're assuming, but there's no margin of error given for
Correct.
that location, right?
Correct.
You could be there, but it's an unknown margin of error, and the FAA doesn't even publish that.
Yeah.
Bottom line is, this experiment is highly suspect because of the margin of error. And given that you're trying to differentiate between 1.25 nautical miles, and most of these things, I think you said, are only rated when there's 10 nautical miles out.
Yeah.
Right? So I would say that if you were to bring this to any physics professor, even a graduate student, even an undergrad who's studying physics, they would just laugh at you because the margin of error is so nebulous that it makes the whole experiment inconclusive. So, and you're going to have to, and this is not an experiment that any individual, any citizen can do. You have to hire someone who can fly a plane. You have many, many variables, unknown variables, and you're trying to predict something which is 1.25 mile difference, given all these margins of error which will accumulate. Or the data you'll get, you don't know what the answer is.
Yeah. I want to point out that the 1 point whatever nautical mile difference was their incorrect globe model computation. That's why, of course, I'm not going to strawman theirs and they shouldn't strawman ours. I'll produce our model, you produce your model.
Not specifically why we left out any flat Earth mentioning in our presentation whatsoever. We did not want to be accused of strawman or poisoning the well or anything like that.
Yeah, one of the things philosophically we wanted to do was each group is supposed to stay in their lane based on their assumptions, come up with their models. That did not occur with the sun model. Massive disaster for the flat earthers. In this case, I think the outstanding issue is the margin of error. Does that summarize it pretty well to both sides?
Yeah.
That the margin of error is a big differentiator.
Yeah. Their prediction is within our margin of error.
And if I talk about the glide slope real quickly, I just want to give a quick analogy so that way Kevin understands that I know what he's talking about when he's talking about the interference pattern between the two signals. So when the two signals are being out, one's at 90 hertz, one's at 150 hertz, they create an interference pattern. Some is constructive, which adds to, which is the beam you're trying to follow, or I'm sorry, one is destructive, which cancels, which is the beam you're trying to follow, and one is constructive, which is the noise on the outside of it. So you can kind of think of it as in like if two speakers in a room with two different noises, right? And you're trying to find a center point in that room by gauging how much you can hear from each noise. So, you know, at 10 nautical miles, you know, because of this pattern and everything else, the signal to noise ratio is going to be almost 20 times less than the actual noise. The signal is going to be like, you're trying to find a needle in a haystack and a haystack of noise to try to find the one needle. And the only way you'd be able to actually measure that would be professional receiver equipment, professionally installed with someone with special training to be able to tap into the closed ILS system to identify where the nearest part of that beam is and the most signal, where the highest signal ratio is. And that's just not an option.
So is that why you're saying here when they're flying in, that line, they just have to be in between those triangles because of the nature of the problem itself?
Correct.
Yeah.
And it goes into, that's kind of like the reasoning behind what Mike was talking about with where it doesn't matter where you are on the glide slope, as long as you're in the glide slope going one way or the other, you're going to land at the same place.
Yeah.
So we've shown the rate of diamond. You were talking about that we didn't look at the rate of diamond changing, but we showed it in the animation how the diamond is changing. And when we assert that you average a large data set, this will take care of nearly all of measurement of the error margin. So we have this result, which was 1% of flat and 10% of the globe. So if you do this hundreds of times, and you can just look if it repeats like that, or it will show very much off for one side. So it's a legit experiment. And we show the error margin with 0.12 degrees are enough separated with, and we also showed this 75 meters. I think you didn't get this, that we also include this in the formula on the last page. But the main point is that you do it hundreds of times and the margin of error is averaging out.
Well, Kevin, let me just ask you a simple question. When you're flying in, you don't know if you're in the center of the beam. That's the point.
Because Toon doesn't know that we use two beams. It's
No,
wrong.
I know full well. Stop strawmanning me, jerk.
But you showed one beam.
No, wait.
How many times is that?
I'm asking you, Kevin, I'm giving you an opportunity to everyone listening. If you're flying in an airplane, there's a center of a beam. Even when you have two, Mike just said that it's the signal to noise ratio is so significant, you cannot predict if you're in the center of the beam. That's why right here in the same instrument you showed, they have a little line with these two triangles. Because of the nature of ILS systems, you never know if you're center of the beam. So you're sort of there. That's the point. So even if you're using two beams, three beams, whatever the fuck, how many ever beams you want to use, even your two beams, the signal to noise ratio is so significant, or the noise to signal ratio is so high that they know that you can't, even when you're flying in an airplane, you're not perfect. So you're sort of, once you get in the range, as you get closer and closer and closer, you come in. So when you want to predict this, I think 20 miles out, you don't know where the fuck you are.
But you talk about interference. You talk about interference level. This is not what the glide is
noise.
It's about signal strength.
Yes. In the center of the beam.
The FAA, the Boeing has very sensitive tests. That's where we got our margin of errors from.
No, but I think you told last time that when you're flying in, when you're 20 miles out, you don't have to be perfectly in the center. You have to be in that cone, the range. Okay?
No,
so you're trying to calculate.
But no, you compare the signal strength of them both. It will receive the signal strength and it will know which beam is stronger and which is less.
Well, I think what you've done here, as you guys, and I'm starting to believe, the globe earthers, you come up with a nebulous fucking experiment. And the experiment was supposed to be the sun experiment. We gave you this, you came up with some nebulous nonsense here, which is inconclusive, and you didn't produce any model for the sun. So you're always trying to have the cake and eat it too. So you lost here too.
No, we talk about 20 nautical miles and not 500 nautical miles, where you could talk about
It's
too much
inconclusive.
of a beam divergence.
Maybe you should go back to 8th grade and bring this to your physics teacher and he'll laugh at you.
I know this is your level of arguing. I know. This is the problem why we cannot talk with PhDs,
Your science
because
is,
you're biased.
no, we're
You're
not
biased.
No, we're not biased. We actually do the scientific method, and you don't. You think by attacking someone who actually has done the work that you can be dilettante, and it's bullshit.
We have done the work, and it's much closer. It's 9% closer to flat than the globe.
You didn't do the globe prediction though. Kevin,
you didn't do the globe prediction.
You didn't do it.
Oh, that's interesting.
You put your tail between your legs and you ran because you couldn't do the globe prediction.
We have the 0.12 degrees here.
And to attack people who are competent because of your incompetence shows your level of duplicity.
I'm not attacking. I'm
You are. You're saying you have a PhD, therefore I'm competent.
You don't look at this experiment. You try to bamboozle it off because you're not wanting more results to be done.
You're the bamboozler.
And
everyone knows that. Everyone watching.
We have that cone of a radius to the tune of 0.12 degrees, and there's lots of models which are kinematically equivalent. We have kinematically equivalent models, but this is not what we're talking about. We have so many variables in the sun.
You don't even know.
We have so many variables in the sun that you don't look at. The gravity is off. The medium. You want to do an experiment with the sun, which you cannot touch.
No. Here's a bottom line. To everyone listening, we actually have a woman who actually flies an airplane. She just joined us, okay? And Kevin, you've never, I don't think, have you flown an airplane overseas and have you done this measurement? I don't think you have. So.
He's muted.
Yeah. Have you done this experiment yourself?
We took the camera from the pilots. That's completely enough. And Stone flies the flight simulators since they are on. Flight simulators are very, very good. Talk with Stone about them.
No, okay. No answers. Okay. So I'm going to end this here because it's 2 p.m. And my conclusion of this, as someone who's been a sincere scientist, is that the flat earthers, at least from what I've observed here, are fucking full of bullshit. They can't produce anything, and they're making money, and they're taking advantage of people who are ignorant. They're ignorant. It's like dumb versus dumber, dumb and dumber, that experiment. So that's what the reality is. Yeah, go do the experiment and see if it'll hold up. Okay? Go do it, Kevin. I dare you to go do it. And go do it. Okay? Because the sun experiment is out there on December 21st. We're going to confirm it. But flat earthers need to get the fuck out of the way because they're taking advantage of people. And we live in an environment where there are real things that government do. And it is my conclusion that flat earthers were brought into this equation to manipulate people. And they did this because there are real things that government is doing against people. And when you pollute it with this kind of nonsense, anything that government does that is real is not taken seriously because of these fucking idiots, okay? Today, we've seen that they could not produce a model, a mathematical model after a week to show, using their assumptions of flat Earth, where is the sun's position? Number one, failure. Number two, disastrous failure. Number two, for their experiment with the airplane, margin of error is significant that it's a useless fucking experiment. So anything they do is always inconclusive so they can keep this grift going. And I suggest to anyone listening that they take these fucking flat earthers and put them in the dustbins of history. And let's move on to real issues that govern our lives, that are significant issues that government has done to us. And let's not let these flat earthers pollute it, because today you saw how they cannot answer a question, how they don't come with anything organized, and complete disorganization. Okay? That's all I have to say. We'll take any things from the audience. I want to let the audience participate in this. Let's go to, I'm just going to randomly choose people. Michael Griffiths from the United Kingdom. You've been observing this. What's your view? You can unmute yourself. We're random people here. Michael? Rose, Catherine Suisse? You can unmute.
Yeah, hi, this is me. I have found this whole thing extremely trying. And I have to say, Kevin, I really was looking forward to hearing some coherency from you, but you were not able to answer a direct, simple question most of the time. And you were on a defense of yourself, for one thing, but also on the offense of a model that you don't fully understand. Now, I don't understand scientific process, well either. And I was here to learn it, to have collaboration, to push, to learn, to laugh, to look. And all I saw was you sucking my life force. That's what I felt, actually. I felt it. And I'm sorry that this happened. And I'm sorry you're walking away without resolution. This is chaotic. It's negativity. And I wish someone like you could just admit that you don't understand something simply, which is what all humans have to do, and that's the truth of the reality in the moment. And then we can move on to something clean, coherent, truthful, and collaboratively real. So for me, this was a pain in the ass, actually, watching you hold up cards because you cannot speak like a human being. I'm wondering if there was something, people are trying to help you. You got a lot of grace. You got a lot of space, a lot of chance to kind of recalibrate here, your center, and it never happened. And I'm sorry it happened. Could have been and could possibly still be a momentous happening for the globe. And I feel like it was just shat on. That's what I feel. Sorry. That's what I do. No, sorry.
Thank you, Catherine Suisse. Let's go to someone else listening here. Rose Cias. Rose Cias, what was your impression of what you just witnessed? You can unmute yourself. Jolanta Siamak. Jewel Monker. Yeah.
Hello?
Go ahead, Jewel.
Yes, real briefly. I'm one of those relatively
You're fading in and out. Let's go to Anna H.
Yeah, hi. I'm very disappointed. I thought everyone would bring their own equations and numbers and follow the rules and scientific method, and this didn't happen. So disappointing from the factors.
Let's go to Joanne Feaster.
Mute.
Go ahead, Joanne.
Yes, I was flying today in my airplane. There's so many variables, including altimeter settings, weight and balance, everything. And it was just painful. I just wanted to see an equation that would account for all the variables. I think there's still an equation out there if we could put one together. So I was really disappointed in that.
Well, the globe earthers actually came up with an equation, Joanne.
Yes.
But Joanne, what do you fly? Can you fly these kind of airplanes?
Yes, I am familiar with ILS, and yes, so there are variables. It's not perfect as far as the measurements and everything, but yes, okay. Altimeter settings, everything. Yeah.
So is it Mike Toon was saying when you're flying into ILS, you never know if you're in the center of the beam exactly. Is that true?
Yeah, that diamond position isn't a guarantee of being in the center. It's just it's figuring that the two values are approximately equal of the two strengths of the beams. But there's nothing in the certification that requires it to be anything specific. So it's really challenging to identify where within the beam you are with any precision.
Rose Cias, I'm sorry, I muted you. I think you were going to say something. Suresh, you can also see if there's anyone on social media who has any comments before we close out.
You know, Dr. Shiva, we can also add in, because we didn't even account for this, we can also add in the fact that these antennas are mechanically aligned and that a shim, because I've actually aligned antennas, the shim is going to be a 0.5 degrees plus or minus on either side. So that 1 degree could make a difference of, I don't know, 1,800 feet of position. I'm just doing some quick math, not the actual math itself. So that's quarter of a mile or half a mile, no, or a third of a nautical mile. You know, there's other variables we haven't even touched.
Yeah, look, we came into this with good faith when I first offered this nearly a month ago to a hooligan by the name of Dave Weiss, and he didn't take it up. And then he waited like 9 months when I re-offered it, and we set parameters that we could do. And then he was invited and he chickened out and ran. A guy called Witch Shit ran. And then when we called him out, then he tried to come back in. So Kevin, there's apparently multiple flat earth groups out there. One flat earth group run by Dave Weiss is who Kevin, this individual, is part of. And he's been duplicitous because he acted as though these were his experiments, and you can go review the videos. In fact, it was an experiment, an inconclusive experiment that was proposed by a guy called Stone who was not invited. So I just want to say that it appears the flat earthers, the way they run their grift is come up with experiments that are inconclusive and then keep attacking the globe earthers, okay? And use globe earth formulation. What we have done over the last 2 days, last week and this week, is we gave the framework of the scientific method, which is very hard for these guys to absorb because A, they dropped out of school. They didn't want to do the math. They think they're chikier because they don't want to do the hard work. Like they're somehow smarter when they're actually just fucking dumb and lazy. So what's happened now, we've created an environment of these flat earth grifters who are manipulating others by doing inconclusive experiments, randomly vomiting scientific terms. They have no idea what they're saying. And fundamentally what occurred over the last 2 days is we imposed the scientific method, come up with the mathematical model. They were unable to do that. Unable. They failed. So everyone out here should recognize the actual criminal type of behavior these guys are doing to people all over the world. There are real conspiracies against people, and those are the ones we should focus on, against working people. And these people are promoted, put out there to distract from that. That's my final conclusion on this matter. And no, we didn't uninvite Dave. He said he could not come. I have the emails. That's a lie. And the other thing is the flat earthers have actually threatened with physical harm other people when they go out of their way. And this is fully documented. So people need to do a little bit of investigation on who is behind flat earth. There are the conscious people promoting this, and then unconscious useful idiots like Kevin who are part of it. Maybe a nice guy, but he's an unconscious idiot. All right. I'm glad we did this. It's very hard for me to go off like this, but I had a conversation with Ryan on this. The issue is when you do the work, you have very little tolerance for ignorant people, for actually people who are taking advantage of people. And that's what is going on. I want to thank the globe earthers for putting in the effort for some very cogent, clear representations. And I want to really repudiate these flat earthers who are absolute fucking deceptive bullshitters. End of fucking story. Thank you. Be well, be the light.
Bye, Kevin. Bye, Kevin. You lost. You look stupid. It's just me and Kevin in here now. He's talking to himself. Cry more, Kevin. This is pretty funny. Pretty funny, Kevin. That was an epic fail. Thanks a lot. I really appreciate, Kevin, how poorly you made Flat Earth look. You did make them look a little insane, Kevin. So thanks a lot. It's been fantastic. Bye.
Kevin, if I may say something, the way you're acting, you should go back to YouTube and look at how you're acting. I mean, come on, man. The time and energy you're putting in like debating, oh, what color the chain is. The bottom line is we all have chains, okay? That's the chain we need to get out of. But you are like, oh, it's a red color, oh, it's flat. The way you are behaving, it's really unfortunate. And like Catherine said, you're sucking the light. Like watching this, like I wasted 2-3 hours of my life, which I'm never gonna get back. And the rest of the people, we could have advanced humanity. If you put this energy, right? Look at you. You're not even listening. You should look in the mirror. You should look in the mirror how you act as a human being. Are you being beneficial to humanity by acting this way? No. Can you participate in a discussion in a civilized manner? No. The way you're acting, look at you. Why don't you go and learn your model? But you know, it's waste. Flat or round, you are getting fucked. Your lifespan is going down. Your children are going to live less than you. Do you know that? Cost of living is rising. But you are here like all almighty, coming and speaking, the way you're acting. I mean, you should look in the mirror. I really don't want, like, I have faith in humanity. I hope you will change sometime in the future. But the way you're acting, right? There's like 10 people watching. It's like despicable. You should be embarrassed. You should have your children, your spouse, your parents look at how you're acting, how you're behaving.
There's 480 people watching on my stream.
And can they listen to me? Can they hear me?
They hear you too, yeah. It's
just unbelievable. Kevin, if you put this time and effort in advancing humanity, like there's a 0.0001% controlling humanity, okay? They're fucking us over. Your lifespan is going down. The cost of living is rising. But you are fighting over, oh no, the chains that we are in is in this color. It doesn't matter what color it is. You're being fucked. And the way you're acting, it's just, man, I like that Catherine said in one word, like, it's like soul sucking. Listening to you, it's like soul sucking. And when people ask you yes or no question, why can't you say simply whether it's yes or no? My goodness. Do you have a model? No, you could have just say no. You don't have a model. Why are you beating around the bush? Wasting everybody's time. If we all got our shit together, we spoke with conciseness and clarity, I mean, we will create heaven on earth. 8 billion people, but we are distracted with the bullshit. We're distracted, whether the earth is flat, ILS. You're creating some crazy experiment like flying. My God. People have to fly, and then there's to be certain like height and like unbelievable, man. You could use your life to help your community, your neighborhood, your country, but you are being suckered into this some sort of a bullshit, some experiment which you didn't design. It's unfortunate, and you're trying to fight for someone else's theory. It's like a Trump supporter coming and saying, "Oh, Trump this, Trump that." You have to fight for yourself. Fight for you. Why are you fighting for some idiot, some other model? You have to look at your life. You're being sucked into some weird group of people, and they're using you. They're wasting your life. You are brought into this world to create something, to build something. At the end of 2025, think of yourself. What have you achieved in 2025? Have you made your life better and the people around you, their life better? Or you just wasted everybody's time? You have to think like that. Just unbelievable that we in 2025 we are behaving like this. You have to do a lot of self-reflection, man. The way you're behaving is just, you have to go back and watch how you behaved, the things that you showed. sorry to say this as a fellow human being. Michael, you have your hand up. Go ahead, Mike, let me unmute you. No, this is Michael Griffith. He's from leadership team in UK. Go ahead, Mike.
Hi, sorry, I noticed I was asked to mute earlier, but I was called away on another phone call. But yeah, I got the gist of what you're trying to say to Kevin.
Mm-hmm.
Kevin, you know, get hold of yourself. You're talking pure bullshit. You know, all this stuff that you're talking about, you're being manipulated. Why are you allowing yourself to be manipulated? Today, you've been shown what the scientific method is, and you're just stuck in your own pit. A lot of people are. And like Suresh says, you know, ultimately, who gives a fuck what shape the Earth is? Because there's more important things at play.
I think Kevin left.
This doesn't serve us, the people, the ordinary people of the world. You're being manipulated.
All right. Well, Kevin left. They're still talking, but they don't know that he's left. Anyway, wow, that was quite something. And having the people then give a little bit of extra beat down to Kevin. Shiva called me, just as that's who called me. So anyway, let me read these super chats and I'm gonna wrap it up here. This was absolutely amazing. Wayne That's Not a Dick says breakfast and Tuesday. Woot. Thank you for that. Cygnus Step says tech is hard, apparently. Peck said flat at. Anush did a member super chat to link the model. So PD194 created the initial model and then Yanush updated it. It's on my website. It's fantastic. Go have a look. Yeah, Yanush did a lot of work on that too. So Jeff Stucco Rikers says, I can't wait to hear the Flurfs experiments, finishing my coffee now so I don't spit out my nose and destroy another monitor. Absolutely correct. Stefane Venny says his flat assumptions, me equal duh. We don't know. Yeah. Duh, we don't know. That was it. Oh, it was so bad. I no model. He just complained about the globe. Hates stairs for $5 says Flurf on Flurf infighting. Ha. Yes, I love it. Ooh, Dark Helmet is running right now. I can hear Dark Helmet upstairs. You know. Conspiracy Music Studios says this is hilarious. Kevin is not tall enough to ride. Correct. We got Wayne That's Not a Dick again says for $10. How did the Flurf presentation survive? Oh, to shreds you say. And what about Kevin? Oh, to shreds you say. Oh man, Kevin, he was all sweaty at the end. I don't know why. Janusz Takis says my top 3 favorite flat earth debates are the 2 occasions when Flurfs tried celestial navigation against FTFE, Ruhif, and this one. This was quite something. I mean, it wasn't billed as a debate, but you know, kind of is similar. Grug, very generous, gifted 20 memberships. That is awesome. Thank you so much. Hope the people that received them express their thanks. You got Rossi says Durst likes to delegate embarrassing contacts. I'll be traveling, Will, but Witsit is super nice. And now, hey, Kevin, you go bend over for this. Broken Trifold says, was the challenge to find the most complicated way of looking for curve possible? Well, that's all that flat earthers can do, because the ways that are simple and are easy to control and have high quality contradict flat earth. So all of them they've looked at and they're like, oh, that doesn't work. Let me go find something super complicated and try that. Here's the thing. It would not, show flat earth in the end. The problem is they suck at methodology. And so their methodology that they proposed was not going to work. They gave a specific number with no margin of error for globe and for flat. And neither were going to be the number that they got. They were going to get a different number. And then what they would do is they would say, oh, well, the flat number was closer to the number we actually got. Therefore, right? That's not how you do it. If it's not, if you give a very specific number with zero margin of error, well, then what? then if it doesn't hit that exactly, and if you declare no margin of error, then it better hit it. Of course, it never would. Anyway, Clem's for 10 Canadian says, this is great. Thank you. Well, thank you to Dave, to Flat Earth Dave, for being on Shiva's to put this together initially, and then run away like a chicken. Charles Arnold says, ILS gets the pilot closer to the runway. Kevin thinks it lands the plane. Kevin was going on about the two beams. Like, I understand the two beams. It sends out two beams, and the ILS display, the flight display in the cockpit, shows where you are in relation to the strength of those two beams. That's what it does. Kevin wasn't measuring the beams. He wasn't going to have a device that was measuring the beams. He was going to use the primary flight display. And when it got to the middle, say, that's our distance right now. What's the precision of that? Unknown. How close to the center of the beam are you? Unknown. What's the precision of the distance measurement? Oh, he didn't think of that until I said it. Of course. Inquisitive infidel says, Flurfs, saying a number is set makes it true. Yep. Again, inquisitive infidel for $5 says, error margins are the skin that ideal formulae gain by coming into reality. Oh, that's a nice way of putting it. Yeah. Like, because of the imprecision of this particular measurement, our margin of error was plus or minus 4 nautical miles. Can it be more precise? Potentially you could tighten it down a bit, but without going into some sort, without having, probably an awful lot of effort put into doing a better job of narrowing the measurements down. It'd be really difficult because that's not what those tools are designed for. So for example, what is the actual angle? Is it 3 degrees or is it 2.9, 2.8? How would you determine that? Well, you'd have to measure that somehow. And the way to measure that would be to construct a tower some distance away from the transmitter, and then change your height vertically and measure the actual strengths. That'd be one way, but that's pretty stinking difficult to do. And if you went far enough away, then you would need to include the computation for the curvature of the Earth in that, which of course is the thing that is at question. So you couldn't do any certification that relies on knowing the shape of the Earth. Makes it really difficult then. Slithery says, my 2 lesbian friends bought me a gold-plated timepiece for my birthday. I think they got confused when I said I want to watch. Oh my gosh. Naughty. Dan DeMann says, Kevin is such a failure. Unbelievable. He is. Jack Fetter says, I'm shocked. Who could have predicted this? Well, I think we all knew. There was nobody that didn't know it was going to be a crash and burn. The question was, what was the flavor of the crash and burn? Would he bring an actual flat Earth model that predicts the location of the sun? Well, he sort of did, and it was the one based on the globe. So good job. Shedsy49 says, thanks, Mike. Thank you very much, Shedsy. I appreciate that. And then Butch Convoy with a member super chat says, bonus milestone chat. Woohoo. Gradings all. Thank you for that. Okay. I finished it up. Shedsy says flat Earth always fails. In fact, it does. Well, I think that an appropriate outro is going to be one because who brought this to us? Dearth brought this to us. So I think it's very appropriate to honor how much he really, brought this to us by playing a little outro for Dearth. Thank you so much, everybody, for joining and for the super chats and the support. Be sure to spread this around because, my goodness, Flat Earth died today. 1,000 deaths. Anyway, I'm back on Tuesday night, Tuesday night, if you will, and we'll see you then.
Yo, listen up, it's your boy Birch in the his house. Plan so slick, gonna make your pockets house. I got an app that's gonna change your life, but before you download, let me slice through the strife. They say the earth's a globe, but I beg to differ. I'll make you believe, I'll make you shiver. Spectroscopy needs a container, that's my claim. I've got no clue, I just hang my head in shame. Yo, listen up, it's your boy Dirt H in the his house. That's the his house. Got a plan so slick, gonna make your pockets house. I got an app that's gonna change your life, but before you download, let me slice through the strife. They say the earth's a globe, but I beg to differ. I'll make you believe, I'll make you shiver. Spectroscopy needs a container, that's my claim. I've got no clue, I just hang my head in shame. But that's the light I'm preaching. Sell my app, it's what I'm seeking. Fake challenge, try your luck. While I'm laughing, pocketing a buck. I'm a scammer.
I'm a scammer.
I'm a scammer.
I'm a scammer.
Flat Earth, that's the lie I'm preaching. Sell my app, it's what I'm seeking. Fake challenge, try your luck. While I'm laughing, pocketing a buck. I'm a scammer.
I'm a scammer.
I'm a scammer.
I'm a scammer.
Yo, Dave Weiss is a scammer. Talk about Antarctica, the icy place. Offered a free trip, dangled it in my face, but I won't go. It's not about thrift. I'm staying home, gotta protect my grift. I'm a scammer. I'm a scammer. Yo, Dave Weiss is a scammer. Talk about Antarctica, that icy place. Offered a free trip, dangled it in my face, but I won't go, it's not about thrift. I'm staying home, gotta protect my grift. I'm a scammer. Antarctica, that icy place. Offered a free trip, dangled it in my face, but I won't go, it's not about thrift. I'm staying home, gotta protect my grift. I'm a scammer. The scammer, I play the game. Gonna hustle hard, gonna rise to fame. But remember one thing, it's all a ploy. To make that green, I'll be your decoy. So if you wanna join, come take my hand. But beware the tricks, it's all planned. TITRH, that's my name. In the world of scams, I got the fame.
I'm a scammer.